deploy. This is
Oh,
amazing.
well, I'm glad we didn't pick Friday. Oh, we're live. Howdy,
You don't
everybody.
want to deploy on Fridays. This is an unspoken rule, no matter how much you trust your infrastructure. Wait, are we live? We're live. This is awesome. Sorry about that. Welcome to day 2 of HashiTalks Deploy. This is going to be exciting. We were just reviewing technology and deployment days and also the schedule for today, but also the schedule for yesterday. If you were here yesterday, you had the great foresight of enjoying a day of really, really good sessions. I can't tell you which one was the best one, but looking at the YouTube stats, y'all seem to like everything. I appreciate that. Our speakers appreciate that. So I want to start out by saying real quick that without you, the audience, this event wouldn't make sense. Thank you for being here. Without our speakers, it wouldn't make sense to do this event because you would have to listen to Taylor and myself. And we both know you're not here for that.
Yeah, stand-up is a different thing. That's
Stand-up is definitely a different thing. So with that in mind, thank you all for contributing to this. My colleague Cole posted something on Twitter, gave me a shout out. I appreciate that a lot, but I'm not the only one making this event happen. I want to give Abby, Rosemary, Taylor a huge shout out. Also the rest of our team who helps us review these talks, helps us edit things, and sometimes helps us catch the things that we want to be catching. Doesn't always happen this way, but we're humans, we learn from this, and we will deploy better the next time. So before we get into the schedule for today, quick word on our code of conduct. Get the rough stuff out of the way first. As with all of our events, we have a code of conduct. We require you to be welcoming, inclusive, and friendly. This is a professional environment, so please conduct yourselves in the same way that you would if you were in the company of your peers, because you very much are. Be considerate and be respectful. If you see something that makes you go like, hey, this is a red flag, tag us on Twitter, let us know. Send us an email. We're HashiTalks@hashicorp.com. Somebody will take care of this. We want everyone to feel safe and welcome, and this is very, very important to us. Next up, if you want to join the conversation for other reasons, #HashiTalks on Twitter, the YouTube chat. Most of you have already found the way there. I can already see Angel is there, Arnold, Abby. Wow, do we also have people not with an A? Tobias, there we go. This is beautiful. So many people, so much good content, and I am very, very excited to kick off today's session with part 2 of what Ray talked about yesterday. Jamie, who also works on the Waypoint team, will be talking about deploying on day 1 as a Waypoint user on day 2 of HashiTalks Deploy. And with that, switch over.
Fantastic. We'll get this all loaded up, and we'll see you in just a bit.
Welcome to deploying on day 1 as a Waypoint user. My name's Jamie, and I'm an engineer on the Waypoint team here at HashiCorp, where I work alongside Ray, whose talk on using Waypoint with OIDC you may have seen yesterday. I'm coming to you from my mum's house in the east of England, so if you hear the sound of children running around in the background, you'll have to endeavour to take it in stride, as will I. For the purposes of this talk, we're going to step back into the world that Ray created yesterday, and I'm going to adopt the role of Jamie intern at Kranzcorp. As an intern, I've been given the traditional task of creating the company's intranet. I've been told that I need to deploy it to the company's Kubernetes production cluster. The only little problem is that I don't really know what Kubernetes is. I don't know where the production cluster lives. I don't know how to access it. And if we're being honest, I'm not sure I even should have access to it. What I do have, though, is this email from Ray telling me that when I'm ready to start shipping, I should check out Waypoint. Well, I think I'm ready to start shipping, so let's check out Waypoint. It looks like I can authenticate using the Kranzcorp identity provider that I'm already familiar with, so let's try that. the familiar blue, the familiar green login screen. I'll put in my credentials. And we're authenticated. Okay, I mean, that was easy. Before we deploy anything, let me show you the app first. I know how to boot it up locally, so let's see that. Yarn dev, and it looks like it's built, so let's go visit it in the browser. What do you think? Quite handsome, I think. I mean, granted, I pulled most of it from Tailwind UI, but as a starting point, I think this will do nicely. So let's see about deploying it. Create your first project here. Okay, project name, let's call it Kransnet. And we're all about GitOps at Kranscorp, so I'll connect to repo for sure. Okay, create. Git source URL. Okay, I guess I can go to the repo and grab this, so let's do that. Okay, I'll copy that. I'll take it back over here. Paste it in. Okay, git ref. Let's go with main rather than head. And I've already set up an SSH key for this purpose, so let's use that. Username git. And paste it in just here. Okay. Waypoint HCL config location. Well, I know I don't have it in the project repository, so I suppose let's go with the Waypoint server. Okay, I think now is probably a good time to go read the documentation. Let's see. Waypoint HCL, overview. Okay, rather than watching me read all this, let's jump forward in time to the point where I've figured out the minimal config, and let's talk through it. So I've called the project Kransnet. I've declared a couple of variables here, Docker username and Docker password. These are variables that we'll use further down inside this config file. So then I've declared an app called Web, and I want to build it using Pack, which is the Cloud Native Build Packs plugin. Apparently doesn't require any configuration. I want to push it to the Docker Hub registry using this other built-in plugin, Docker. I will label it JG White Kransnet. I'm going to tag it with this git ref pretty helper function, and then I'm going to make use of those two variables I declared above. And then once things are built, we will deploy and release using Kubernetes, which also apparently needs no configuration. Okay, I can't believe this will work right off the bat, but let's try. Initializing, oh, okay. Yeah, there was no way. So let's see. Unset variable, Docker username, a variable must be set or have a default value. Oh, of course, I declared the variables, but I forgot to give them any values. Let's go do that. Input variables, okay. Let's add our Docker username in here. Docker username, JG White. I'll save that. And then let's add Docker password to go along with that. Please don't steal my token. Okay, let's see what kind of effect that had. Initializing again. And the web app has appeared. I guess that worked. Let's take a look what's inside it. Okay, nothing so far, but there is a big inviting blue button in the corner, so let's press it. Authing with SSH, as we said. Building web. Maybe if I have a look in that builds tab, I can see what's going on. Building with Pack. That's right. Get some output data. Okay, well this is going to take a couple of minutes, so let's skip forward into the future again, by which time Waypoint has released the app web, deployed it, having built it, and emitted copious build output from cloud native build packs. Let's go and take a look at that deployment. Deployment v1 deployed by Kubernetes. It says it's available. All 2 resources are reporting ready. And dare I click on that URL? Cransnet lives. It's all there, present and correct. And even better, I've got a real URL that I can share with my manager, the designers, my colleagues, and Ray herself. This is wonderful. What next? Well, if we know that Waypoint HCL works, I guess I could now commit it to the repository. Let's do that. So if we go back to project settings, let me go copy this Waypoint HCL. And let's go now back to my editor. I can stop that dev process. Let's make a Waypoint HCL file. Paste that in there. Yeah, it's all there. Okay, let's commit that. Add Waypoint HCL and push. Okay, now let's flip back over to the Waypoint UI. And we can flip over to pulling the config from the project repository. And now we might as well turn on automated deploys. I don't see any reason why not. I feel like I'm getting pretty comfy with the Waypoint UI here, but I imagine there's even more power to be unlocked by using the CLI. So let me do that. I've seen that button in the top right this whole time, luring me in. Looks like it's a one-liner. I'll copy that. Go back over here, paste it in. Okay, that's all looked like it worked. How will I try this out? Maybe the project list command. There's my project. How about Waypoint status? Status. That's looking good. Let's zoom out a little bit. Great. We've got that running. So now I'm kind of curious, what does my deployment actually consist of inside of Kubernetes? Let's go and see if Waypoint can tell me. So here's my deployment. Let's click on in here. So deployed by Kubernetes. It's available. We've already seen some of this. It's telling me what image it used, and that git ref pretty, and the commit that triggered this this build as well. And then below we've got some resources. So the resources created by this deployment, a Kubernetes deployment, a Kubernetes pod, and then for the release, a Kubernetes service. Let's take a look inside the pod. I assume that's where the action will be. So now I can see the health specifically for the pod and some labels and lots and lots of state JSON. And I imagine if I knew anything about Kubernetes, then I'd know what some of this meant. Let's take a look at the service just for comparison. Similar kind of thing. Okay, well, how about let's take a look at it in the CLI. I happen to know if you pass the app flag, then you get a bit more info. And so here we can see application summary, deployment summary, resources for the deployment, and for the release. Great, I feel like I'm really building up some momentum with Waypoint. Next challenge, let's change the app a bit and deploy again. So let's do something simple, really, really simple. We'll add in a new announcement to the list over on the right. Here's the data, in turn deploys app. So let's commit this. Say like add announcement and then push. And then we will magically jump forward in time again, at which point we find a second deployment has automatically appeared. It's available. Do we dare click the link again? And there's the new announcement. Okay, let's check the resources for this new deployment, see what that's all about. So Web v2 deployment, Web v2 pod. Looks like it's sharing its release with the previous one. So just that one service called Web, but that makes sense. What do I do next? What's the next challenge? This is going too quickly. I know. Let's try loading data from a real database. So let's see. What do we need to do in here? Let's take away these statically defined announcements, and then we'll need to send them in as a prop. That should be all the changes we need to make here. Now let's jump up to the next thing above. Okay, and let's paste in some data loading logic right here. Okay, so I'm importing the client library, implementing this get server-side props function, connecting to the database, and then performing the SQL statement, and then returning the response. Next, I think I'll need my main page function. I don't know very much about this framework, but I'm led to believe that I need to then plumb these props into this right here. And then I guess I need to send them further on down into that home component. Okay, I think that's everything. Let's try it out locally. Seems to have compiled. Let's go visit it in the browser. This is just using a local database at this point. And there's my announcement. Okay. Well, this works locally, so let's commit those changes. Git commit, say load data from database, or load announcements from database. Okay, and then let's now figure out how to get that to work on Waypoint. So let's read the docs again. I basically want to set up that environment variable. So let's have a look into how you do configure environment variables. So we go app configuration, dynamic values, internal values. Let's start with the overview. And as we've done before, let's jump forward in time to where I've read enough of the docs to understand what I need to do. Let's add a config stanza to my project. Now, I've been told by the SRE team that there is a database for me to use in this production cluster, and there is a Kubernetes Secret that Helm put in place, which I can pull the password from. My app has permission to do that. So let's first set up a variable that just pulls that password. So this is an internal variable that we can use elsewhere. It's going to dynamically pull its value from Kubernetes, a secret called DB PostgreSQL, and the key within the secret, PostgreSQL password. Now what we'll do is define the envars we want Waypoint to manage. We've got one called dbURL, which you saw earlier when we did this locally. We're going to interpolate config internal DB password in there into this overall URL. And I know the database URL because, again, I've been told it by SRE. Okay. Let's make those changes. Add DB URL config to Waypoint. And let's push. Okay, well, again, this will take a little while to rebuild and redeploy. So let's skip to the future, where I've got a new deployment. It's available. Dare I click the URL? I dare. There it is, it's live, with my one announcement from the database in the production cluster, hooked up to my app, all managed by Waypoint. I'm feeling quite proud of myself at this point. What might be interesting to see is if my app has access to that database, that database, maybe I can access it from within the context of the app. Let's try that. So if I went waypoint exec bash, that'll give me a shell in the context of my deployment. Notes Heroku in there. That's because we're using cloud native build packs, which are built on Heroku tech. So now I can use that DB URL that Waypoint is managing, and I can see my announcements table, and I can select the announcements from that table. And there it is. So let's recap what we've managed to achieve. I went from an app that I only knew how to run locally to deploying it in a way that gave me publicly available URLs, to deploying a next version and getting 2 distinct deployments, both of which I could view, to hooking up a real database, and having Waypoint manage the config variable that makes that database available to the app, all in a completely declarative way, without having to know anything about Kubernetes along the way. I mean, ultimately, I probably would like to learn Kubernetes, but for right now, my main concern is deploying the application. So I hope you enjoyed everything you saw so far. That's all from me. That's all from me, and it's also all from Transcorp, the fictional company for this demo. The eagle-eyed amongst you will have spotted numerous places throughout the talk where timestamps in the UI betrayed me and gave away the fact that this wasn't really a continuous recording. But I hope that the impression was, the fiction was upheld anyway. So thank you so much. Enjoy the rest of HashiTalks deploy, and I hope you check out Waypoint soon. Oh, one other note. Some of the things you saw in this demo are from the main branch of Waypoint, not necessarily in the current release version, but they will be in a released version very, very soon. So without further ado, I hope you enjoy the next talks and see you very soon. Bye-bye.
Truly fantastic.
That was just good. I love the dare I parts. We've all been there. The thing I enjoyed most was Ray yesterday hinting at 0.7 features, today getting a preview of 0.7 features. And now it's here. This is, well, it's not here, but it's here on the screen. And by the time you view this recording in the future, 0.7 will have landed. This is all just very exciting. With that, I think it's time for our first Nomad Talk of the day. Very excited to introduce Forrest Anderson, who's been a great help in our community, running a community Discord, helping people out in spare time, figuring out how our tools work, and bringing people together. This is my favorite kind of work. Forrest, over to you.
Perfect. Let's hear more on Nomad for students.
Hello, everybody. Today I'm going to be giving a lightning talk on Nomad for students. And so a little bit about myself. My name is Forrest. I'm a student in Ottawa at Carleton University. I'm a Rustation, so I like writing Rust code, and I really like Nomad. And so a little bit about the context of this talk. I've been using Nomad at Carleton for several months now to deploy a few applications, and I want to take a look through what this process looks like, but more from the student's perspective. And so a few tech specs of what we have. We have 3 server VMs going. We have 3 client VMs that are strong enough, lots of like a 32 vCPU, 64 gigs of RAM. So not a massive deployment, but we can deploy quite a few projects on it. We have 1 ingress IP, and we have definitely less than 100% uptime. That's not the end of the world for us. When I look through Nomad documentation and it says, this is not recommended for production environments, I'm like, but we're not a production environment. And so from the student's perspective, students have projects a lot of the time, right? Like if they're doing something for a resume, or if they just want to try something that's pretty cool, oftentimes they'll be doing some type of web project or something that will need some type of back-end deployment or front-end deployment or whatever. And so this is sort of what the objective of our Nomad cluster is being able to give students the ability to do this. But from a student's perspective who's just come in and just done their first Ruby on Rails tutorial or React tutorial, and they want to get something deployed, they're going to hear quite a lot of things once they get started in the deployment world. And so one of the obviously like the biggest things they're going to hear is like, what's this cloud thing, right? And so like the cloud can sort of be generalized as just a lot of computers that are somewhere else, and you can connect to them and you can run stuff on them. But that's really what they are. And then, I mean, the next step that you would take once you go down this rabbit hole a little bit is like this idea of cloud native. What's cloud native? Well, it's sort of like a lot of services that are running together, but the cloud native is also like a lot of levels of abstraction on top of that, right? Like we want to be able to reason about a lot of these services. How are they being run? How are they being started? How are they connecting to one another? And so there's a massive world of things under the umbrella of cloud native, but it's really about like the art of running services like at bulk. And so, of course, like the next thing that students are going to hear about when they go down this path of looking to deploy and finding the sort of like largest way, like the most popular way to do this, they're going to hear about Kubernetes. Hopefully they hear about Docker first, but let's say that like they're going to hear about Kubernetes somewhere. And so the thing for myself is when I got started learning about a lot of this world of cloud native and this world of deployment, it seemed to me like Kubernetes is really the only option that I had like to be able to use. And so I think that for myself, I really started by going out and looking in the Kubernetes community and seeing that there's like a lot to not just do with like production usage, but home lab usage and side projects, and a lot in the world of Kubernetes. And so this is like a really great thing to see. There's like a massive community, so many people using it. It's used at these big companies. But then as soon as you start going down the rabbit hole of trying to learn it yourself, there's a lot you have to do. There's a lot of configuration to set up your first cluster. There's a lot of terms that you have to understand, even for like the most basic deployments. And if you want to have any production environment at all, there's a long list of steps that you have to go through, from installing Kubernetes on your machine or on your cluster, to being able to provision certificates, to having different like control planes and all of this stuff. And from the outside, you can go and watch a lot of tutorials, but there's a lot to do. And so this is what brought me to Nomad, is that I was looking for other alternatives out there, and I wanted to find the term for that thing. Like I just want something to run my my services. I have my Docker containers. I really like using Docker Compose on my one computer, but when I want to deploy, I need what is it that I need to be able to run these services? And so the word I was looking for was orchestrator, and there's really not a ton of options out there for orchestrators. But in looking around, I found Nomad. And this was sort of my entry into the HashiCorp world, where I then found a lot of the other products that are available as well. And so essentially, like for me, the biggest things I found really nice about it was that it was just like a refreshing exit of like all of this terminology that I didn't want to know right off the bat. It gave me a single binary that I was able to start running some applications with in some simple dev mode, and a single purpose. And so I don't necessarily have to consider all of the things that I have to do to get this one thing running. Instead, I can just say, okay, well, I'm going to start by running one service, and it ran. I'm like, oh, okay, that's pretty cool. And let's try a little bit more and a little bit more. And then, of course, that leads you down the path of a lot of different tools that can work together. But the very core principle of orchestration is what it focuses on. And so at Carleton, we run several projects out of our Nomad cluster. And so these stem from projects that students have started with the something that a student has made for students to use. But we also have a few other services running here and there to help either with some introspection into the cluster or some just backend stuff or anything like that. And so we also keep all of our code open source. And so the idea behind this is we want students to be able to come and learn how stuff is done and then be able to sort of enter this world of becoming their own SRE. Like people can go and set this up themselves. So just a quick overview of the sites that we have that are running. So this one right here, discretemath.ca, was created by students who wanted to help create practice problems for the second year discrete math course. And so this is one that a lot of students struggle with. And so this site just has previous midterms that the professors have posted, all aggregated together. And you can go in and do questions. And so students saw this problem, students created an application to solve this problem, and then needed some way to host it. So we have university infrastructure, and this is sort of where I bridge the gap. Is that like if we take a look at like what's being run here, we have the back and the front end and Postgres, and you can run that on a virtual machine just by itself. But then as you start scaling and as you start adding more potentially microservices or you want to build a second project or something, then there's a lot of technical burden that can come up down the road. So the second project we have is called Merged, and this is a way to show off projects or events that are being run at the university by the different technical clubs. And so I can see the events, I can see when they are, and I can see if I click on it, it will bring me to the website that is relevant to. So I just want to take a look here quickly at some of the code that comes along with this, or rather is used to deploy this. And kind of just, if you know Nomad, this is really nothing special. We're using traffic as our ingress, or our reverse proxy rather. We're using connect to connect the backend in the database. But what I want to bring attention to is for a student who doesn't know very much at all about the deployment world, if they were to take this template that is used for merged and then just duplicate it and start working on swapping out the Docker image that's used and the host name that traffic is looking for, then there's really not that much overhead to getting something running on the cluster. Of course, there are a few things that would be a little bit different, like this idea of like a service mesh and connecting ports that are running across different clients. There's a little bit of stuff there, but in comparison to the tidal wave of information that I had to try and set up to configure some Kubernetes services, this definitely feels a lot easier to me and a lot more approachable, especially from students who are just entering this world and trying to teach themselves. All right, and so with this setup that we have, so we're running Nomad at the university right now. This is giving us the ability to run projects that students are creating. And the question that comes up is like, well, can any student use this? If any student makes their own project, are they able to make use of this technology themselves? And we definitely hope that the answer is yes. And we want really for this project to be able to help improve the cloud native literacy for students. So when students are coming into a lot of these ideas, how are they approaching it, and what are they able to do to learn it? And so in the future, we're hoping that we can really expand this out as an ecosystem to be able to teach students through workshops, get more students helping to operate their cluster in a safe way, but then also offering this as a service to other clubs and societies who have their websites that are being hosted in different places and being able to just keep it within Carleton. And so that's it for my lightning talk. You can reach out to me on GitHub, Twitter. I also run a separate from HashiCorp community Discord where I try to encourage people to come and talk about projects that they're working on and help learn together. Please do reach out to me on anywhere you'd like to ask more questions. And I do hope that I can come back for a longer form talk sometime in the future with some cool stuff. Thank you very much.
So cool. Just super cool to see. I love seeing this kind of stuff, especially coming from students. Is it scary that we were not at that level as students? Just moderately. But that being said, definitely a great lightning talk. I'm looking forward to watching this one again when I have a little more time to focus on that. In the meantime, Forrest and all the other speakers, or many of the other speakers, are on Twitter. We have a Twitter list for you, which you can follow by clicking the link that we'll get up in the chat momentarily, as soon as we've figured out how copy-paste works, which is one of the biggest things in technology these days. In the meantime, we'll also get the Discord link up, because I realized that while we could click on the slides that Forrest shared, you might not be able to. Definitely worth highlighting that community. And again, stop by, say hi. For us, for our next speaker, we've got Cole Morrison joining us and talking about, he's a fellow DA, colleague, and I'm very excited for him to talk about a general approach to automating your deployment process and the things he's learned along the way.
I'm really cool.
Friday.
I know that we have infrastructure as code, but this is going to be infrastructure as Cole, if I do say so myself. I'm very excited to see this talk.
Excellent use of words.
Awesome.
Let's kick it over.
Let's do it. See you later.
Alrighty, thank you for the introduction, and thank you for tuning into my talk here, a general approach to automating your deployment process. So what is this about? You know, my fancy title here aside. Well, in any given deployment, whether for infrastructure, code, networking, some combo of all of the above, or maybe even more, our ideal, so our end goal, is often the automation of said deployment. You know, and in this journey, we're going to generally see two camps here. The first camp is so interested in the details and technology that they wind up missing the forest for the trees. And by that, I mean they'll lose sight of the end goal of automation. Why? Well, because they're so caught up in the implementation and doing more faster, right, that the end result winds up being rushed, or even worse, confined to some local maximum that discounts the future or a variety of different edge cases. But on the other hand, the second camp will get so caught up in the higher level phases, so planning, more planning, throw in some business jargon and buzz terms, that they'll miss the trees for the forest. And by that, I mean they'll stretch out and overcomplicate the process and implementation so much that the end result is arguably worse than just doing things manually. Suddenly, their pipeline requires more engineering than the applications being deployed. But wait. What is the end goal of automating your deployment? Well, I'm going to tell you, it's not a continuous integration and deployment pipeline. The end goal here is not the forest or the trees. An automated pipeline for your deployments is just a tool, if you will, to achieve the desired end goal, and that is to save time and reduce error. Yeah, I know, duh, okay, right? No. That may seem obvious, but when you've been in it long enough and you've built enough of these pipelines and talked to others out there that have done the same, you'll really start questioning whether or not that this is the end goal, right? You go to any meetup and ask anyone about their automation pipelines, and be prepared, because the majority of them are going to be either the most complicated, long-winded piece of engineering that you've heard about, or they'll be so simplistic you'll wonder why they even have one. Now, obviously, this isn't the rule, but honestly, sometimes I wonder if it is. So in this talk, we're going to go through key points that make up a general approach that you can take to avoid falling into either of these two camps, both of which are forest on the forest and trees, but I've often forgotten that we're actually just trying to get out of the damn forest. So, who am I? Well, my name is Cole Morrison, and I'm currently a developer advocate at HashiCorp. Now, I've spent the past 10 years in the industry primarily in software engineering and startups, though the previous 4 have mainly been in DevOps, both teaching and doing. Now, if you followed me at all before, taken any of my courses, read any of my blogs, well, then you know I've spent a good amount of time talking about automation pipelines and building them. Well, it turns out that when you're in startups and you're building things from scratch, or you consult them, you wind up building a lot of automation pipelines. And so better or for worse, I've gotten pretty good at the process. And as you can imagine, I've got a lot to say on it. So let's go ahead and get into it. I'm going to show you all the things that we're going to cover here today. So from the many years of going through this process, these are a list of 7 ideas / techniques, whatever you want to call them, that I use for automating deployments. Now, a couple of things here. First, these are in order. You should do them in this order. Second, some of them may seem obvious, but I have some things to say around them that may not be so obvious. And third, just a terminology thing. When I say pipeline, I'm referring to our end result. So a series of automated or manual processes that complete your deployment. Okay, so first thing, that is to do things manually first. All right, I know this may sound obvious, and it is. So let's go ahead and skip to the non-obvious part. When we're seeking to create a product for users, the first step is to what? Well, it's to identify the pain points and problems that the users are looking to solve. The product then becomes a solution. However, when setting up engineering solutions and pipelines, all too often we experience the problem once, twice, thrice, and then suddenly we decide that we're ready to build the whole pipeline. How much do we really understand the ins and outs of what we're trying to solve if we've only experienced the pain a handful of times? Probably not much, right? And jumping the gun here is what leads to solutions that have an incredibly low or skewed local maximum. So what I mean by that is that the solution you come up with may have a ceiling that it can't go beyond. Think of it like building a factory, right? A certain size and setup of a factory may be perfect for creating 1,000 widgets a month, right? But the second you need to create 10,000 widgets a month, well, it'll either be super slow or impractical because the factory wasn't built to do that, because it didn't consider those things or that growth. Now, I know this may sound like, oh, this is only for teams that, rush and build their pipeline, right? No, because I have another curve on here. So the red one that represents overthinking the pipeline. So this would be like creating a factory for building millions of widgets a month, but you currently only produce 1,000. Well, operating infrastructure designed for millions of widgets, only produce 1,000 is a lot of unnecessary overhead. So the first thing to do here isn't just to do things manually first, it's to do things manually many times first. All right, so you do this because it gives you a variety of experiences and perspectives through repetition so that you can truly understand the pain points and problems you're trying to solve. Now, the more times you go through this process, the more you'll experience edge cases, unknowns, and come up with ideas that you wouldn't see if you just hopped right into trying to build things. There's a quote I love parroting from Socrates, and that's understanding a question is half the answer, and that's what we're doing here. Okay, fine, Cole, but how long should I do this? Well, the answer is going to vary for each team and project, but my rule of thumb is until it becomes routine. You and I both know what that means, right? It means your deployment is just another thing that you do. You can, of course, choose to move on earlier or later, depending upon your needs. But the earlier you move on, the less you're going to truly understand things. And the later you move on, well, the more you'll understand things. But regardless of when you choose to move on from this step, there is something you must produce, and that is what I like to call a human automation script, which is really just a thorough step-by-step. And what do I mean by this? What I mean is that before you leave this step, you should produce a document that outlines every single thing that you do as a human to complete your deployment process. So how detailed should it be? Well, it should be so detailed that it could be a Friday before you're going to be gone and unreachable for a week, and you could hand this script to a junior ops or developer and be confident that they are going to do the deployment for themselves and it's going to be completely successful. So step-by-steps, edge cases, consider things to look for and how to solve problems that come up. Human automation scripts. And whether you know it or not, from this script, you've created this solid foundation upon which all of our next steps stand upon. And so let's go ahead and move on to that next step. And the next step is to define the ideal workflow. So at this point, we've got the devil you know, and that's this manual process, right? And surely some of you have been on teams where for your project where step one, so having those manual steps is what you stopped at. But it's frustrating, time consuming, and since manual, good old fashioned human error can throw everything into chaos. But before you go building things, our next step is to figure out exactly how we'd like this process, this new automated process, to work from a human perspective. And what I mean by this is to ask yourself, how would I want to work with this pipeline? We already know what the end result of the pipeline should be. That's the complete your deployment. But right now, we're doing all these manual steps in that human automation script that we made. So after the pipeline is complete, what would that script look like then? So for example, when I was at FieldBoom trying to define our team's ideal workflow, it was version control based. I wanted to do this. I wanted to make some changes to my infrastructure as code, pull requests into our production branch, check these changes on a staging environment. If they're good, merge them into the production branch, and then ultimately have that merge trigger the deployment automatically, right? So I wanted 5 steps, all inside of GitHub, all in code, with everything else moved out of the way. This was the ideal workflow that I wanted to create for our team. And the above here more or less became my new human automation script. And as you can see, this was something I could hand off to anyone well-versed in GitHub or Git. And by the way, at the time, I literally had never heard of the term GitOps before when putting this together. Now, when you're coming up with this workflow, you want to be pretty detailed what you want out of it. And you also don't want to judge it too hard. So what I mean is the whole, is this even possible? Like that question, you can kind of silence that voice for now and let your imagination run wild. Because don't worry, we'll crush those dreams later. All right, so we've got what we're doing, so our manual step-by-step, and we've also got our new ideal workflow that we want to move towards. It's now time to move on to our third step, and that is to research existing tools, ideas, and methodologies. Again, this is not the time to begin building. Instead, it's to see what's out there. You see, you don't want to start trying to construct the pipeline if your mental toolbox is limited. Now, why? Well, let me just throw up another favorite quote of mine, which is, if the only tool you have is a hammer, well, then you tend to see every problem as a nail. This is the exact trap we are looking to escape from. And it goes beyond just equipping yourself with better tooling, but also getting up to speed with better ideas, paradigms, and also existing workflows that others have discovered. This is so you don't wind up reinventing the wheel with sticks and stones, which would be a massive waste of time. The thing is, unless you're building some one-of-a-kind pipeline, and I'm just going to say it, you're more than likely not, other people out there have walked a similar path and have experiences they can share. Other teams and companies have created projects with similar needs and created tooling and techniques to get it done. And now is the time to begin researching, right? So why now as opposed to the beginning, right? Because a lot of engineers will hop right into this step just as much as others will try to hop right into building. And this is generally the area where our engineer Alice will go down the rabbit hole and never be seen again. Well, the difference is that if you follow the first 2 steps, you have a compass and a North Star to follow. You know exactly what you're looking for. This makes the research far more productive because, if you don't know where you're headed, then any road's going to take you there. So a cautionary tale of my own way back in 2015 with an earlier startup. We had our product up on managed rack space, and we were more or less doing everything by hand in a few scripts. I guess we'd just set up on Semaphore CI, so I guess there was that. However, the ideas of cloud computing as it is today, infrastructure as code, those weren't even on our radar. Those mental models weren't in our toolbox until we didn't even consider that as an approach. And thus, the pipeline that we created for our deployment wasn't what it could have been. So maybe infrastructure as code is now on your radar. Well, if you have Terraform in your mental toolbox, then what you can build is far beyond what someone without it can. And if you're still spinning up load balancers for every service in your stack, well, maybe it's time to go and figure out what a service mesh is and use something like HashiCorp Console. And oh, hey, HashiTalks deploy here, right? We've had quite a few talks on Kubernetes. And if you're wondering, hey, can deploying this to this beast be less of a labyrinth? well, maybe it's time to check out HashiCorp Waypoint. The more tools and ideas you have, the better. Now, the biggest pitfall here is truly analysis paralysis. We all know what that is and what it feels like, and there really isn't a straightforward trick here because how much time you can dedicate to research is going to be different based on your situation. Your budget, team, deadlines, all these factors will come into play, but you must set a cutoff. You must say something like, I will spend X days, or I will research Y number of options, and then I will move on. And move on to what? Well, our fourth step, and that is to pick your tools and methodologies. Oh, duh. Yeah. I know, but never underestimate analysis paralysis combined with the paradox of choice. Because once you bring your head up from all the research you've done, you're probably going to find yourself overwhelmed with, the number of options available to you. And decisions are hard. After all, if you pick the wrong tools, as we've discussed in the beginning, you can wind up with a very limiting or inappropriate local maximum. I have all sorts of nightmare anecdotes here from going with the wrong choice because picking the right tools and technologies to invest your time and skills in is a much larger bet with much bigger consequences than we often talk about. And why? Well, because if we pick the wrong ones and we invest, say, a year of our time, and then next year the tool is outdated, unsupported, or becomes the lesser option in the marketplace, our value decreases, and we wind up having to learn all over again. And that's just from a personal standpoint. From a business standpoint, unless you've got enough clout to make whatever vendors you're going with stick around and keep up support, you're likely going to have a painful migration in the future, right? I mean, call me short-sighted, but years ago, I couldn't fathom of why infrastructure as a service would ever overtake platform as a service. I really did think that things like Heroku and all of those other similar services out there were the future. And obviously, I was wrong. And all of my knowledge around those failed pass options is now pretty much useless. Anyhow, I have some criteria that if you keep up with my other courses and videos, you may have seen before, but there's 5 criteria that I use to pick technologies. Now, the first one is how familiar I am or how familiar my team is with the tool or technology. The reason this question is important to ask is because the more in-house experience you have with the tool already, well, the faster and better you'll be able to move. However, the more important side here is that if you have existing experience, you have a much better view of what the thing can actually and truly do. Because as we know, marketing and sales speak can be somewhat misleading. Now, the second is super critical, and that is documentation, community knowledge, and usage levels. I don't care how flashy the tool is, or the technique looks. I don't care how cute their mascot is, and I don't care how big their latest funding round is. If the docs are terrible, building it is going to be an uphill process. If there is no community, answering edge cases and tackling hard problems is going to be a lonely, frustrating journey. And if not a lot of people are using it, how can you even be sure that it'll achieve the scale that you want? Now, the thing is, when choosing a tool, you kind of have to ask yourself, do I want to be the trailblazer for this thing, or do I want to build what I set out to build? Do you want to be the one who discovers all of the bugs and oddities, or do you want to build the thing that you wanted to build? Well, probably the latter. So if these elements are missing from an option, it's probably not an option. Okay, third, and this is something I've made many a mistake in ignoring, and that is the track record of the creators and maintainers. So the other 2 elements are great, but now we need to look at who's behind this option. Is it an individual or a company? Are they active in maintaining and updating their product, or is it a ghost town? Are they receptive to community ideas and feedback, or are they set in their ways? You have to understand that if you're going to pick a tool to serve as the foundation of some critical aspect of your stack or product, well, you better be sure it's going to be active. Back in 2017, when I was tasked with doing what we're talking about here, right? So setting up a pipeline, but also building on a cloud infrastructure. Well, Terraform was still in like 0.11, right? And as cool as it looked, I've been burned before by going with options based on what I want to call buzz factor, right? So I wound up in CloudFormation, and obviously I was quite wrong in my estimation of Terraform. However, at the time, what I was confident about was that AWS would be around. Now, I did wind up moving over to Terraform about a year later, but that's a different story for a different time. And obviously now much of the world that's using infrastructure as code has standardized on Terraform. So maybe this isn't the best anecdote for this point, but you get the picture. So next up, functionality. Does it do what you need it to? Again, super obvious, like most good advice, but it's not always followed. We look at the different tooling and we see, oh, the Fortune 500 use it. Oh, all the FANG companies use it. And our human brains, oh, so susceptible to social proof. Look around and say, well, then it must be good enough for me. But since you have a very clear idea of what needs to be done, you should be cross-referencing both your ideal workflow and your manual step-by-steps you've made with the tools that you're evaluating. And how do you evaluate that? Well, if you've already vetted it for documentation, community knowledge, and usage levels, it should be pretty easy to figure out if it can do what you need it to. And if you're having trouble figuring that out, well, then you probably didn't evaluate the tool in context of number 2 on our list here. So finally, number 5 here. What is more important and viable for you in this tool, control or convenience? What I mean by this is that most tools will generally fall on one of two sides, which is doing a lot for you automatically or giving you all the pieces and expecting for you to set it up. Another way that this is generally worded is how low level or high level the tooling is. So are you working with a bunch of primitives and piecing together the larger system? Or do you have a convenient binary, for example, that you just pass a few settings to and then move on? Now, the right answer here is, of course, dependent upon your ideal workflow way back from the earlier step. For some teams and people, more control is going to be required. And for others, the automagical black box is all that they need. The trade-off here, though, is, of course, that with more control comes far more responsibility and therefore required time and resources. However, with more convenience, you're often left with less optionality, meaning that if your needs don't fit the main use cases of this tool, you may spend many moons hacking up workarounds. Okay, so that was a pretty long segue, but this is a very critical step. Infrastructure and pipelines aside, picking tools and technologies and methodologies are one of the most important things that we do in technology, both personally and professionally. What you choose to learn and invest your time into can either make you the next Kubernetes operator, or it can make you the next Modulus.io operator. And if you don't know what that is, it's because it's not around anymore. Okay, so after all that, we're going to zoom back up to our larger list of steps here to number 5, and that is to create a hypothesis and plan of implementation. So you've got your tools and methodologies picked out. Now we need to draft an approach. What do we think we need to do, and how do we think we need to get all these pieces together to get our pipeline up and running? And this is less about creating some scrumified workflow to get it all created. Sure, that's a component, but there's really 2 things you need to look out for here. So the first is to resolve conflicts between your human automation script, your ideal workflow, and what's actually possible. This is where we take all the dreams of your ideal workflow and realize that a fraction of them, or maybe even more, aren't possible. Now, my own experience was realizing how difficult multiple deploys were with CloudFormation when it came to race conditions, updating only parts of the infrastructure, and collaborating with multiple people on the project. Now, unfortunately, I didn't pay enough attention to those aspects of it, and our workflow, at least for some time, wound up with this whole stand in line and wait scenario, whereby if one fix was going out, then all the other activity needed to freeze. The next thing is to get your team members and stakeholders' input into what should be in the final pipeline. Again, this should seem obvious and maybe everyone else got lucky, but if you've never been in a workflow where one SRE or lead engineer is the bottleneck for all of your deployments, well, then you're lucky. Because it's not fun, especially if they're the one who built it and they're absolutely convinced that it's the only way. Again, good advice is often self-evident, but truly, how many of us talk with our users regularly, aggregate team feedback, and dog food our own products? Yeah. Anyway, the end thing you're putting together is a plan of implementation. The more people involved, well, the more project management you'll likely have to impose. But going into that aspect, and how you might manage this is beyond the scope of this talk. But you have the plan. It's now time to hop to this step that many of us just jump right to, and that is to build the automation pipeline. Now, what else is there to say here? At this point, you're going to implement your plan and get this wonderful pipeline built. However, there is one main piece of advice that I hope you'll take to heart when doing this, and it is this: to build it simply, but leave room for extensibility. The biggest trap here is over-engineering your pipeline into something you might need years from now instead of creating what you need for this year. If we take another look at that chart I showed earlier, again, this is the equivalent of building a factory designed to produce 1 million widgets when you're only producing 1,000 right now. However, the opposite is just as bad, which is why the second part of this statement is just as important, and that is to leave room for extensibility. If you're going to over-engineer somewhere, it should be this aspect, the aspect of extensibility. So let's say you're building your infrastructure as code with Terraform. Well, it might be tempting to do the whole thing in a single project in the root module, but it's going to be problematic as the infrastructure grows. Whether because everything has to be maintained as one, deployed as one. There's many reasons. However, a pattern that's going to leave you with extensibility while still keeping simplicity is going to be to just go ahead and start splitting things into smaller modules. So, maybe you've got one for your network, one for your compute, one for your data, and so on. Although this is a bit tangent about Terraform, when constructing your pipelines for deploying your infrastructure, being able to maintain the different aspects of it as modules goes a very long way. It allows teams to work in parallel, deployments to happen independently, and of course, more reusability. However, what's more important here is the thought process, right? If you're already building with the module mindset, then you're already thinking about creating code that can easily integrate with other code. This means you can start with a simple set of modules and you can add more as you need them versus keeping everything in one big blob and inadvertently playing infrastructure Jenga. But anyhow, that is the one thing to take to heart here. Build it simply, but leave room for extensibility. Okay, so we are on our final point, which is what comes afterwards. Well, that is to evolve our automation pipeline through iteration and feedback. So now we're actually back at the beginning of our list here. You see, what happens is there's still some manual component of our pipeline more than likely. So I gave my ideal workflows earlier, and maybe this is what it winds up looking like after our whole process is said and done the first time. Well, if we're trying to evolve this, what should I do? Well, if you're following our general approach here, it's to do this process many times. As I do this many times, just as when I began, I'm going to continue encountering pain points, problems, and oversights that maybe I didn't see before. And as I familiarize myself with this new workflow, maybe I define a new ideal workflow. Something that would come about by talking, with the different stakeholders and aggregating all of our experiences into this. And you probably see where I'm going here. And that's that this approach is recursive. When I hit step 7, it's time to go all the way back to step 1 and begin again. And this is how you move forward with continuous improvement. This is how, after defining our ideal workflow, we do more research, figure out what's changed, and now we're going to be asking better questions now because we have more information. And from there, we'll pick our new tool and methodologies to further improve our pipeline, form a new plan of implementation, and build it. And then the next thing you know, we've completed the process again, and our pipeline is even better. I bring this up because once we've completed this process the first time, we have that initial version of the pipeline, it's very easy to become complacent. I myself am guilty of this, even though I complained about dealing with lead SREs and stuff that are bottlenecks. I, of course, I've certainly played that role myself. And it's never intentional, and we stop here. We get this up so we can move on to other things, and our focuses just change. But the question of when to do this next iteration, let alone when to do this in general, well, is it in alignment with our original goals of automating our deployment process, which is what again? When it saves time and reduces error. And how much? When it's so much that the time that you save from building this pipeline outweighs the time it takes to build it. So these are the steps for a general approach to automating your deployment process. There are generally two camps that we fall into. those of us that miss the forest for the trees because we're so zoomed in on implementation, we're doing more faster and better. And then those of us who don't even realize the forest is made up of trees because we're so high level, overthinking and over engineering it that it takes forever to build. But neither are the end goal. The end goal is to get out of the forest. In our case, save time and reduce error. If your automation for your deployment isn't doing that, well then what was the point of any of it? Thank you so much. Again, my name is Cole Morrison, and I hope you enjoyed the talk.
Welcome back.
Welcome back, indeed. That was
sobering words, I'd have to say, Kareem. I think that really taking apart what it takes to build a deployment process or automate something, I think Cole was really able to sum up well. I haven't thought of it like that before, and usually it was kind of jumping to that sixth step and then just like, where's the code? Let's get this rolling, let's get this out there. But really nice to take a more thoughtful approach to measuring twice or 800 times and then only cutting once.
I mean, you know what it is, right? Measure twice, cut once, measure once, cut multiple times, try to resolve it. Then I think there were a lot of really, really great learnings in this talk. I think my personal favorite is probably to evolve your automation through iteration and feedback. Day one doesn't have to be perfect. Day one will never be perfect. And hey, you know what? Day 1037 will also not be perfect, but that's okay as long as we keep improving. That's all that matters. With that, I think it's time for our next talk. We've got Mike from the Nomad team here. Yesterday, Mike talked about the Nomad Pack contest and the second iteration of that. Today, we're getting a walkthrough on how to build Nomad Packs. I'm excited for this one. This is a nice abstraction and simplification of workloads.
I agree. And with that, we're going to pack on up and get out of here. See y'all in a bit.
Hey, everybody. My name is Mike Nomich, and I'm the product manager for Nomad at HashiCorp. Today, I want to talk to you about a new tool that we're really excited about, which is called Nomad Pack. It's a new package manager and templating tool for Nomad. In this talk, I want to give you an overview of what Nomad Pack is. I want to go over the various ways that you could use Nomad Pack within your organization. And then I want to dive into the structure of what is in each Nomad Pack. And then we'll go over the process of taking a Nomad job file and turning it into a pack that could be consumed by anybody. So by the end of the talk, you should have a good sense of what the tool is, how you can start using it, and how you can contribute to the Pack ecosystem. All right, so let's jump into it. So what is Nomad Pack? Nomad Pack is a CLI tool that can be used either in your terminal or in a continuous integration pipeline. And it sits between registries and a Nomad cluster. In these registries, we have Nomad Packs, which are groups of templatized job files and variable definitions. Nomad Pack will pull down a pack from one of these repositories, allow a user to input variables, and then send these job specs to the Nomad cluster to run them and manage them over time. So in this example, we have two GitHub repos. One could be public, the other could be private. And a GitLab repo, Nomad Pack will pull these packs down and then send jobs to Nomad, in this case, running Traefik, Jenkins, and Postgres. So let's go quickly over what it looks like using Nomad Pack. So right now I have a Nomad cluster, and I have Nomad Pack locally. So if I run this CLI command, I can see the various commands that I can run. And right now I'm going to list out the various packages that I can deploy. So I use the Nomad Pack registry list command. And so this shows me all the packages that I can deploy. This right now is pulling from what's called the Nomad Pack community registry. So this is a public registry that anybody can contribute to, and we really encourage people to contribute to it. So you can open a pull request, and then your pack will be added to this list. And then when people use Nomad Pack in the future, by default, they will have access to the pack that you've written. So this is what we have right now as options to deploy to Nomad. So I look at this list and I say, okay, I can deploy some cool things. I could deploy Traefik, I could deploy Nginx, I can deploy Prometheus, but for the purposes of this demo, let's just deploy Hello World. So I'm going to copy that. And the first thing I want to do is see, okay, what are the options that I could pass to the Hello World pack? So I will run the info command, Nomad Pack info hello world. I run this, it gives me a brief description of what this pack does, deploys a simple application with an associated console service, and it gives me various variables that I can pass into the package so that when it's deployed to Nomad, I can customize it for my own needs. In this case, we'll just focus on the message variable. So now the next thing I want to do is see, okay, what are the jobs that this would be deploying to Nomad? Each pack can have one or many jobs that it deploys to Nomad. And so let's see what that looks like. For that, I'm going to use the render command. So I'm going to say Nomad Pack render hello world. And now this puts out what the Nomad job spec that this pack defines looks like. So I get a sense of what it's doing. I say, okay, this is a server, a service task. It's a Docker driver, and it's using this mnomich hello world server with this environment variable, hello world. Now, the important thing about packs is that everybody can use them how they want by passing in variables. So I saw that there was a message variable. So now if I pass in the var message equals something, let's say hola mundo. Now when I render this file, oops. There we go. Now when I render this file, this message says hola mundo. And now that's a very simple variable that we could pass in, but as we go, we'll see that we could get really complex with the logic that we insert into packs. So now I have an idea of what this is doing. I can now test what this looks like against a Nomad cluster. So I'm going to run this Nomad Pack plan command, and this says that this will deploy a single job to Nomad, and it would be successfully allocated. All right, so it's time to actually deploy this. So now I use the Nomad Pack run command. I give it my hola mundo message. I guess it doesn't like exclamation points. All right, and now it says the pack is successfully deployed. And now what I could do is I could check the status of this pack. I can make sure it's up there. This now lists all the packs that have been deployed to Nomad, the status command. And if I want the status of a specific one, I can check hello world. And this says I'm running the latest deployment of hello world. It has a single job called hello world, and it is running. So let's check that out in Nomad. All right, so now if we go to Nomad, we see that the hello world job is running. If we click into it, we see that it's a pack, and we see some pack details along with the standard job details. So we see that this pack's name is hello world. It's coming from the default registry, and it's the latest version of the pack. And then if we jump into the actual server that was deployed at the port it's deployed on, here we see that it's saying hola mundo. So we properly took a variable from the CLI, we passed it to Nomad Pack, that put it into the Nomad job for us, and then it deployed properly. So that's a really simple version of running Nomad Pack with the simplest possible pack. Now you could do this with a ton of different jobs and really quickly with a few keystrokes be deploying common applications like WordPress, like Nginx, like HA proxy to Nomad. Now let's jump into the details of what is actually in a pack and how do you make one. Okay, so right now I have opened the Hello World pack directory. So this would be the directory that gets pushed up to the community registry so that other people can use this Hello World pack. So let's just jump into the contents one by one and we could explain what's in there. As a brief overview, we'll have a Readme, a metadata file, a variables file, and then an optional outputs template. And then also we'll have the actual template that makes up the job spec and potential helpers. So first, let's check out the Readme. So in the Readme, when you're writing a pack, you're going to want to write a very simple description of what your pack is, and then how one would use it. And then also call out any integrations or dependencies. So here I say that there's an integration with console, and so that someone who uses this will know, oh, I will need console up and running to potentially use parts of this. And then I call out other integrations that this has so that people could really use it successfully. I'd say in your README, just try to set up whoever the end user is for success. And then also we have a list of variables that can be used, and this gives people a general idea of how they could customize this application for their needs. So that's the README file. Now let's jump into the metadata. So this metadata defines some general information about the app, what the URL of the app itself is. So if this were, let's say, WordPress, this would point me to the WordPress homepage and the WordPress author. And then this pack stanza says, this is the name of the pack, gives a general description, and then a version. And so if I were to, run Nomad Pack info, it would be pulling this data from the metadata.htcl file. Also in the metadata file, you can call out pack dependencies. So we won't go into this in detail in this talk, but packs can depend on other packs. So you could have, let's say, reusable code to keep your packs dry in some sort of helper pack, and then inherit from that in a variety of other packs. So that's the metadata file. Now let's jump into the variables file. So if you're used to Terraform, this will look really familiar. We tried to model it based on the variables that you see in Terraform, and this is running with HCL as well. So here there's a job name variable, a region variable, a data centers variable, account, message, whether or not to register a console service, et cetera, et cetera. And now whenever I run this pack, I could actually pass in different values for each of these variables. So we saw earlier, I passed in the message of Hola Mundo. It overrode the default hello world, and then that rendered that to the screen. In this pack, I see by looking at the variables file that I could pass in a different count. So I could potentially run 10 of this pack, and then I could also say whether or not to register a console service and what that console service's name is. So it's really important when you write a pack to figure out what you want to create variables for, how you want to parameterize the pack. I would say that it's important to strike a good balance between parameterizing too much or too little. If you parameterize too little, it's really not that useful of a pack. You might as well be sending somebody a job file and having them figure it out from there, because they can't customize it to their own needs. If you parameterize too much, it's also not that helpful, because they have 50 variables to read and try to figure out how to actually use the job. So I try to strike a good balance there. So that's the variables file. And then lastly, we have the actual templates themselves that define the Nomad job specs. So these are created in the templates directory, and any job that you want to deploy to Nomad as part of a pack gets a .nomad.tpl extension at the end of the file name. So if I had multiple jobs that this pack wanted to deploy, I would say name of job.nomad.tpl. Let's jump into the hello world job. So this job, you can see, looks roughly like a normal job spec, except you'll see some delimiters, the open brackets and the closed brackets. And we'll get into that in a second. But you see that normally it looks like HCL, except for that. Now, Go template is what's being used with these delimiters. So whenever I open a double bracket, it says that I'm using the Go template templating language here. This allows me to do things like inject variables. In this case, I'm injecting the message variable. It allows me to do things like call helper functions. So here I'm using the quote helper function that says I'm going to take this message and pass it into quote, and then it's going to render that into the job spec. So in this case, it's going to take whatever my message is, wrap it in quotes, and we'll have message equals quote. So that's a really simple use of Go template, but we have actually more complex uses. So here we have some conditional logic. So this is saying if this variable exists, then render anything in this block to the HCL. So now I could get a little more complex. I don't just pass variables in, but I could actually, completely omit or skip certain stanzas. There's also the ability to use helper templates. So here in Go template, we're using this region template, and we'll see what that looks like here. All right, so this is the helpers file. And what this does is it defines templates that can be used elsewhere in your code. So for instance, if you had, let's say, a console health check that knew that every job was going to be using, you could define a console health check template and then insert it into various jobs. In this case, we have two very simple templates, one that defines the job logic for a job name. If the job name is equal to nothing, give it the name of the pack, and otherwise pass in the job name variable as the name of the job. And here we have another one, the region template that says, if the region is not equal to empty string, insert the region value here. And so this logic gets inserted right here into the Nomad job spec. All right, so really quickly, let's see this in action. Let's use the register console service variable. So if I am the author of this job, I can use the render command to see what this job spec looks like. So I'm going to give it the render command with the var register console service true, and we can test out the Go template logic. So I do this and I see that, hey, yes, this service is being rendered. So everything in here was properly rendered. Now if I give it a false value instead, we see that the console service was not rendered in the job, and when this gets pushed up to Nomad, no console service will be registered. So that's a really simple use of Go template logic to parameterize values and pass in variables into packs so that you could customize them for various use cases. All right, so now that we know what the contents of a pack are, how to use Nomad Pack generally, let's go through the process of actually writing a Nomad Pack ourselves. So the application that we're going to packify is something called Nextcloud, which is a productivity suite. It can kind of be thought of as an open source, self-hosted Google G Suite or Google Drive. We're going to take that in Nomad job spec form, and we're going to convert that to a Nomad Pack. So at the end of all of this, what we want to do is push something up to the community such that anybody now can go install Nomad Pack and say Nomad Pack run Nextcloud and get this productivity suite up and running on their self-hosted cluster. This is something that's been really popular for people who run home labs or are really into self-hosting, but it's also something that's also often used by big enterprises if they want an alternative to G Suite. Okay, so let's get into it. All right, so here are the basic steps to writing a Nomad Pack. First, you want to start with a Nomad job spec, and we're going to assume that you know how to do that. If you don't know how to do that, there's some resources online. You want to start with something that you can push up to Nomad with a Nomad run command yourself, and then we'll work from there. Then you want to get some basic scaffolding. We'll show you how to do that. Then you want to input the metadata and the Readme information for future users. And then you want to go through this process of identifying parameters. So these are all the things that could be variables in your Nomad Pack. And you want to figure out, okay, what are the things that I actually care about allowing people to customize in this pack? Then we are going to go through each of those parameters and parameterize the template. We're going to make a variable, and we're going to pass that variable through to the templates and conditionalize what we need to conditionalize, input the values where we need to input them. So we do that for each of these parameters. Then we're going to test our pack locally. And then lastly, we're going to contribute by pushing up to the Nomad Pack community registry. All right, so let's start with our Nomad job. And I'm coming into this with this job already written. And let's go through it really quickly just to see what it contains. So it's job Nextcloud, has some basic information on region, data centers, namespace, etc. It has a constraint that says that it will only run on Linux. And then it has a task group. And this task group has a couple of tasks within it. They are connected via a bridge network, so that means they share a network namespace. We have a couple ports that are static, and this is because I know that the virtual machine I'm running it on has these exposed. So I want my HTTP port to be exposed on 4001, and my DB to go to the Postgres port that's conventionally 5432. Then I have my application. This is running Nextcloud's latest image. It mounts a volume from this directory on my host to this directory within the task. This is conventionally where Nextcloud expects this information to be. It has a resource stanza, and then it has some common environment variables. Now, Nextcloud can be run with a Postgres database or a MySQL database. In this case, we're running a Postgres database, so we have these environment variables exposed. As you can see, it's very secure. And then we have the database task. So this is running Postgres again. I have kind of an older image being run because I know that that works. Someone else might want to use a different image. We'll get into that in the future. And then I'm mounting another volume here for the Postgres data. Again, on my machine, I know this volume exists here, but on someone else's machine, it might exist somewhere else. And then more environment variables and more resources. So it's a relatively simple job, and I know that it works. I've tested this before. I'm able to run this job. So let's just start from that assumption. So we've written a Nomad job. Step 1 is done. Let's get to step 2. And let's get some basic scaffolding. So I'm going to pull down something here, this example Nomad Pack registry. So it's a repo we host within HashiCorp, and it could give you just a very basic registry to get started. If you wanted to write your own packs, this is where you could start. You just clone this template. And right now we see that the Hello World pack that we're familiar with from earlier is in here. So I'm going to clone this, and we'll start using this as the basic scaffolding for our pack. So we'll take this and we'll actually convert this from a Hello World pack into a Nextcloud pack. Okay, so I'm back here, and I've now taken the working Nomad job. I've plopped it into this pack that we got from that scaffolding, and we see that it's a Hello World pack. Let's see what we now need to change. So first, we need to go and change this Hello World name to Nextcloud. We also have some variables that are referencing Hello World variables. And then also we have this output that is specific to Hello World. We have this README that's specific to Hello World, and we have variables. So I don't want to, make you sit through all of this. So what I'm going to do next is I'm going to change the names of all of these references to Nextcloud. I'll change the name of this file. I'll delete any of the variables that we don't need. And then in the README, I will get rid of everything that we don't need. So with the power of video editing, I'm going to do that right now. All right, so I removed all the information that was specific to the Hello World job. I've replaced Nextcloud. I've renamed it Nextcloud where it needs to be renamed. I've gotten rid of all the variables except a few, and I've cleared out the README. So I think step 2 is all good. All right, now it's time to input metadata and the README. This should be pretty quick. All right, once again, through the power of video editing, this is done already. So I just dropped in a brief description of what Nextcloud is, some caveats about how you would run it successfully. I called out dependencies saying that it requires Linux and it may or may not need console. More on that later. And then I left the variables blank because we haven't yet identified exactly what the variables will be. I have some ideas that I spelled out here, but we'll go into that soon. So that's the README, and the metadata, similarly quick. Drop a brief description, a name, and some links to attribute the author. All right, so that is step 3. We're done with that. Now it's time to move on to step 4, identifying parameters. All right, so I've taken the working job spec and I've dropped it into the template file, but not much is parameterized right now. So I think what's important is to go through this and see what assumptions are we making about our environment that might not be true for other people's. And then we'll make a list of those, and those will be our parameters that we'll pass in as variables into this pack. So the first thing that jumps out to me is this constraint, this Linux constraint. So I might have only this constraint, but other people might have more constraints. They only want to place this job on, certain nodes in their system. So we should allow people to add their own constraints. That's one. The next thing that jumps out to me is the network stanza. So I've assumed that I want a network stanza and I want these static ports. These ports are static on my machine because they're opened up to the outside world, but on other people's machines, they might not want static ports. And actually, we advise against static ports on Nomad. So this is, again, something that we'll want people to be able to customize with the variable. So now we have the network and the constraints as our 2 parameters. Let's keep going. So now the next thing that jumps out to me is the image. I'm using the latest image, but a lot of people like pinning images. So we might want to pass this in as a variable. After that, I realized that this mount is making some assumptions about the system too. I have my data at this directory, but other people might have their data at some other directory. And so we should make this mount customizable. Same thing for the Postgres task that has its own mount and also its own path for the source data. So there's that. And then next up, I realized that these resources are custom for my system. So I'm planning to run this in a home lab. I can run this with relatively low memory and relatively low CPU. Other people might be running this for an entire enterprise, and they might want much higher memory or CPU, or they might want lower memory or CPU. So that should be customizable as well. And then lastly, these environment variables. I'm making some assumptions about the admin and the password. And also I'm hard coding in the Postgres password, which isn't good. A lot of people want to use Vault. They'll want to pass in a stanza that says, or a call to Vault saying that they want to grab that password from Vault. So that's something that should be parameterized as well. And then lastly, there's this question about whether this database task should exist in this pack or not. Now, I want this database task because I'm running this on a single node. I want this database running in the same namespace. But in the future, I might be running a database, let's say, on RDS or on some managed database service. And I won't want to have to deploy this database on my node myself. I'd just rather point to it in the future. So we can probably identify that some people will not want to run this task at all, and they'll just want to run this application task. So that's another parameter. All right, so now we've identified our parameters in step 4. Let's take a look at the list. Okay, so I've added these two variables, Nextcloud image tag and Postgres image tag. I give people a description and a way to find all the options, a link, and I inject my defaults as what I was using previously. Now that these variables are here, I can inject them using Go template into the template. So here, for instance, our old code looked like this. It was using a specific image, and our new code looks like this. It's using the variable. Let's test this out really quickly. So I go to the terminal, and now I can render and pass in this image tag as latest. When I do that, we see it's using Postgres latest. When I don't use the variable, it uses the default. Great. Now let's move on to resources. And for this one, we'll use a helper template. All right, and now we have two more variables. We have this app resources variable and DB resources. This is a little bit more complex than our other one. It's an object variable, so it takes a CPU and memory value for each. And you can see that these are the values that we were passing in before as the default. Now when I use these, I'm going to use them with this template. And so our old code looked like this, and our new code is calling this template. And it's the same thing above in the application task. So this template gets an argument, which is the database resources variable. And then you can see how it uses it. It takes the argument, it assigns it to this value resources, and then it prints out the resource stanza. And this is a nice dry way to write our code now. Next up, volume mounts. Okay, so this is our most complex variable so far. So this Postgres mounts variable defines a list of objects. Each of those objects have a lot of keys, type, source, target, etc. And then bind options has a list of objects itself. And our default is right here, and this is what we were using previously in our template. So let's look at how this is used. So in the template, we're passing this variable into the mounts template, the mounts helper template. So let's look at that. This mounts helper template, defined here, takes the argument, it iterates over it, and for each mount, it creates a mount stanza. And then it injects the values from the variable into each of the keys in the stanza and iterates over each of the bind options to create a bind option stanza. So that was volume mounts. And I'm actually just going to skip past the others as it's a very similar process. You add variables, you add logic, you templatize, etc., etc. So let's just go to the end now. And the last step we have is to test this and then contribute. This is the fun part. Now we have a fully parameterized job spec. We have a constraints parameter passing into a constraints template. We have the network being parameterized. We have environment variables being parameterized as well. Optional console services being passed in. And then also this conditional saying that if you include the database task, you'll add a database task, but if not, don't render a database task. And then lastly, I've added this pre-start task that creates data directories on the host using raw exec. This is optional. Again, this is off by default, but if you run this, it'll make it easier for people to use the pack without doing pre-existing setup. And that's really important. So let's test this out. Let's go to our terminal. Let's render it once just to make sure it works. Okay, that looks good. We'll run a plan. Okay, that looks good too. And then we'll do a run. And this is now pushed up to Nomad. Excellent. We'll give it a second for the images to download, and then we'll check back in. All right, the images have downloaded, so we'll pop in here. We'll check out this task group. We have one allocation. We have our pre-start task, and then we have our application and database task. This application, if you remember, was running on port 4001. So now if we go to port 4001, we see that we have this login, and we gave it admin and password as the admin password. And now when we log in, it works. And now we have an instance of Nextcloud up and running. And now we just have one step left, pushing this up to the Nomad Pack community registry. Once we push this up and it gets merged, anybody will be able to run Nextcloud on their Nomad cluster with just one command, Nomad Pack run Nextcloud. So here's my pull request. I give a brief description of what Nextcloud is, and I create the request. And there we go. So that's it. We've gone from a Nomad job to a Nomad Pack. And I hope throughout all this you now understand what Nomad Pack is, how it works internally, and more importantly, how you can contribute going forward. I really cannot encourage you enough to contribute to the Nomad Pack community registry. It's something we're really excited about. We've already had a great response so far. It's something we're going to continue investing in the coming months and years, so please stay tuned for more around Nomad Pack and its integrations with Nomad. Have a good one.
Welcome back.
Thank you. This was amazing. Mike's explanations of how Nomad Pack works are just beautiful. And just as a reminder, if you were here yesterday, you know this, but if you weren't, Nomad Pack is not just software. Nomad Pack is also this beautiful backpack that you can win by taking part in the Nomad Pack contest. We'll have a link to the blog post and the contest up in the chat later to help you figure out if you want to contribute. And of course, the answer to that is yes, because you should, because it helps everyone. It helps you to bring your workloads in a more useful way, and it helps everyone in our audience and everyone else using Nomad Pack. Taylor, any comments or thoughts on this session?
Yeah, I'm really excited to see what people create with Pack, honestly. I know that talking about how we package up our applications for our favorite container platforms and orchestration frameworks has been difficult. You know, there are a lot of options out there. So being able to have something that you can instantiate with Nomad specifically is going to be a lot of fun to take a look at and to see. You know, I know I've worked in the world of Kubernetes for quite a while, and so Helm charts have been the way that I've done that. And templating has been difficult in some aspects. So really excited to kind of, take a look at Pack and see what we can do there, as well as use Waypoint to get that deployed too. So quite excited on all fronts there.
Absolutely. And I think Shantanu has a great call out here saying that we need graphs to see contributions before and after the talks by Mike. I like this idea. I think we just need to keep track of that and see how this evolves. With that, I think back to you, Taylor, and our next speaker.
Awesome. Our next speaker is Mark LeBlanc, and his title is Here for Deployment Time, Not a Long Time, a Waypoint and Vault story. Always excited to hear when people can kind of fuse all of these different HashiCorp tools together to create really interesting workflows. And with that, it's no secret that we'll be kicking off this next session. Have a good one. See you soon.
Just point us to the way.
Hi, everyone. Thanks for stopping by to listen to my HashiTalk. Here for deployment time, not a long time. So does that make you think of a song? It should, because it's intentional. Great song, great band. If you don't know it, go look it up. So who am I? My name is Mark LeBlanc. I'm a delivery leader over at Arctic. Work with a great team of consultants where we focus on automation, CI/CD, microservices, and the lot. Part of that job quite often finds the HashiCorp stack part of the discussion. The talk today is around why ephemeral credentials at deployment time matters, and it involves the two tools, HashiCorp Vault and Waypoint. Waypoint's a little newer. I've been using it for a little bit, but I think it's really interesting. It has a good part of this story. So let's hide my face and get into the talk. See if this works. All right. So what is the problem that we're talking about? I have this kind of lengthy, wordy description here, but really what we're talking about is the fact that secrets management has become so complex. The systems we're dealing with are so complex. They're so sprawled. Things are very dynamic in nature. Things are coming up, scaling down, they're scaling out. And we have very known risk associated with poor secret management. We all know, if we're not doing secret management properly, there's the risk of making the news for a data breach, for a database breach, for an infrastructure breach, someone stealing your IP, right? So what are the risks with poor, what are these risks? What's going on here? So anyone that's worked in operations or production or any kind of IT role, really, we know some of these things that I've put on the screen here. We know there's too many static passwords and secrets. We know there's too many plain text secrets. We know that secrets are being mishandled. We know secrets are not being rotated. I'm sure if this was a live in-person event and I said, who here is aware of a password that has existed for more than a month? I'd have some nods. I bet if I said, who here is aware of a password or a secret that's existed and not been rotated for more than a year, I think there'd still be some nods. It probably could go even beyond that. The next one I have here is apps and developers are not ready. So what I mean by that is when we talk about HashiCorp Vault, yes, we all know it's a secret manager, but how ready are our applications to consume these? How ready are those developer teams? Are they aware of Vault and what it means to integrate with that? Quite often they're not. The list goes on and on. All of this puts your infrastructure, your data, your IP, it's at risk. These are the things that keep us up at night. These are the things that we worry about and we hope we never have to deal with. And if we do, we wonder how are we going to handle that? So that's kind of what we're talking about when we talk about secrets at deployment. Some of the benefits that I see when we talk about secrets at deployment time are the automated secret generation. So I don't have to go to a sysadmin or a cloud admin or a database admin and say, hey, can you generate me an API key? Or can you generate me database credentials? It's all automated. The other thing that's a really strong benefit is the automated secret rotation. So when I think about the Vault dynamic database and secret engine for GCP, for example, I can have it so that the password is rotated automatically, the username is rotated automatically at whatever interval that I want. So specifically in the demo we'll show you in a few minutes here, I have it set to rotate every 30 seconds. So that time to live for that credential is very short, a very narrow window. So even if someone did gain access to my system, the chances of them being able to grab that credential and do anything with it, it's much harder. The other thing that I really like about this is the automated revocation of those credentials. So if I want to pull back all my leases from Vault, I can do that, and then those secrets are done. It's gone. It doesn't even exist to possibly be an attack vector. So a really strong set of benefits, and those are just a few. I'm sure there's 100 more if you could think about them. So the toolbox for this talk, the demo, is Vault, which is a secrets management tool, and Waypoint. Now, I kind of pulled a silly description of Waypoint out of Wikipedia definition, which is very literal. What is a waypoint? But Waypoint with HashiCorp is really a nice tool to improve developer experience for the SDLC. So it'll help you do your build, it'll help you do your deployment, and it'll help you do your release. So specifically why I picked these two tools for this talk is there's integration you can do with Waypoint and Vault. There's a couple different ways to go about it, and I'm going to show both. One is a very native integration where Waypoint kind of handles everything, and another one's where, I wouldn't call it a cheater mode, but it kind of is, where we're annotating container pod deployments with the Vault agent sidecar. Both are fantastic, and there's benefits to both, and I'll explain them once we kind of show it. So why are we doing this? Again, think back to those benefits. One, it's ephemeral. It's a short-lived secret. We're going to grab it for when we need it. And then when we're done with that deployment, it's gone. It's automated. I'm not going to have to call up anybody. I'm not going to have to put in a ticket. This just happens, and it's just there. The automated generation, the automated rotation, and the automated revocation. It's fantastic. Finally, I keep talking about, like, what if someone gets in? It's audible. So because it's all token-based by Vault, you can see when someone grabbed the token, where they came in from, what they did with that token, and it lets you kind of narrow in on, what was that blast radius. Okay, so let's just talk quickly about the demo agenda. I have a very simple Go application. It's Vault unaware, so it doesn't have any native calls to Vault. It's going to rely on Waypoint to get that information into it. It's going to make some assumptions that things are available, and it just does its thing. We're going to do a deployment where it's broken, so we haven't set up the Vault integration. Then we're going to, in the second point, we're going to update that deployment so that it includes dynamic credentials, and that'll go out to Vault, say, hey, give me some database credentials. It'll spit them back. It'll go do its thing. The third thing I'll show you is very native Waypoint and Vault integration, where the pods that the app is running on is not necessarily aware of the secrets. It's being injected through an extra layer of Waypoint called entry point that'll get built right into your image. And then the last thing we'll do is we'll just take a little poke around at some of the visibility gains that we get. We'll just sort of check the audit trail that we can see and see some of the things happening, see some of the calls back to Vault. We'll see when the username and passwords get updated and those sort of things. All right, so let me switch some screens here and we'll get right into it. So I'm going to hide this one, pull up my VS Code. Okay, so on the right, we're not going to look at the UI of Waypoint, but I just want for awareness, there is a UI you can log into. I don't really use it too much. I tend to be more on the CLI. Okay, so just to lay out kind of what this demo is. So there's a Google Kubernetes engine. I've pre-built that. We have Vault installed on a namespace. Part of that installation on GKE is we've installed the Vault Kubernetes auth method. So what's going to happen is we're going to build this application I've called Hello Creds, super simple. When Hello Creds comes up, it's going to be running as a specific service account the Vault knows about, and it's going to say, hey, yeah, you have access to some stuff. Specifically, we gave it access to a database engine and a KV pair with a little bit of host information. Okay, so what are we looking at here? I have on the screen Waypoint config file for an application. And so I mentioned that it helps you manage your build, your deploy, and your release. So I can just show quickly. I want to point out one thing right now, because we're going to make use of this in a moment. This config section here for env, this is for defining environment variables. So right now this is just empty. We're going to come back to that in a minute. And this would be made available to the Waypoint, the entry point layer that runs with your application. Next thing it does is it can do the build. So I've already pre-built this image because I don't think we need to sit and kind of watch a build happening. But we can see that it's pushing up the GCR, giving a tag, marking it as not local. For the deployment, we're going to say deploy it to Kubernetes into a namespace called Hello Creds. We have some empty annotations. Same thing, we're going to come back and see that in a few minutes. Here's that service account I was talking about that it's going to rely on when it boots up. And we're going to say run on port 80. Okay, so that was the build and the deploy. The last phase of what it's going to do for us is it's going to do a release. Same thing, we're going to say use Kubernetes. I'm going to do a release in the Hello Creds. And what it's going to do is it's going to push out a Kubernetes load balancer for us. So let's just go ahead and kick that off. I'll just pull this up so you can kind of follow along. This can take a couple minutes. Sometimes it takes a second or two for it to grab an external IP address from the load balancer. So we can see that it's created. The deployment successfully rolled out. So the deployment phase is done. So notice it switched from deployment. It says releasing now. Now we're waiting for that Kubernetes load balancer to come up, be ready. And while that's doing that, I'm just going to switch and make sure I'm clicked into the right browser window. Because a couple things are going to happen here when this is done. One of the neat things that Waypoint offers you is it does offer you a proxy service. So when it first deploys your application, there's a proxy service that you can kind of use as a preview window. It's not meant for any kind of production level traffic, but you can kind of go and see your application without having it released. So we've done the release as part of this, but we could have just seen it here. So here's the very dry vanilla version of the application. We see that it's complaining about no database credentials and it's complaining about no Google Maps API key. So let's just take a look for a second. So kubectl, let's just check out our services. So we see that it built us a load balancer, grab that external IP address. We can see that it's got our pod running there. Not too exciting. Okay, let's go back. And the first problem we're going to take care of, we're going to first take care of this database credential error. And how we're going to do that is on our deployment, specifically here, we're going to add some annotations. And they've got them pre-cooked over here. So for anyone that's done this before, these annotations are going to set up the Vault agent sidecar and set them up in a template. So I'll show you really quickly here. So it's going to go to a path in Vault called database creds my role. It's going to grab some database credentials, and then it's going to create a template for the pod. It's going to basically dump the username and password onto the path. The other thing it's going to do is it's going to grab database host information. Same thing, going to dump it onto using a template into a specific file. So let's just save that. And I want to just get rid of that old deployment. What did we do wrong? Let's look. Try that again. Fun with demos. And away we go. So again, it can take care of the destruction too. So if we just go back real quick, we'll just look. We'll see there's no pods in that namespace. And the load balancer takes a few minutes to come down, but that's okay. We don't really care about that at the moment. So, okay, let's just review what we did. We did one deployment. It was broken. We've added the annotations. We're going to deploy it again. And while that does that, I'm going to make this half a window. So we can see this other one when it's ready. Deployment rolled out. Waiting, waiting. Waiting. We can actually show you that this proxy URL is dead. So remember, after I did that first deployment, we did the destroy. This is gone. Just waiting for this to become ready. Service is ready. There it is. So it's a new one. Specifically, you'll notice that it's got a new version. So there, that's cool. So we have a working call to a database now. So we can see that it's got the working code over here. We just added those annotations. And what's neat here is I want you to watch So right now I have these credentials are going to rotate every 30 seconds. So we can actually do two. See if we can do this. Okay, check this out. So every 30 seconds, this username and password is going to rotate. So if I refresh this now, we're going to see that it's changed. But check out this log coming out of a Vault. So what I have on the left hand in my VS Code here is I'm streaming the log file from Vault. We can see that it had an expiration to revoke the lease. Oh, just refresh again. But my point is here, you can watch this very clearly. You can see the request for the new credentials. You can see that it's revoked. You can see the new ones being requested. Let's get out of that. Okay, so we've gone ahead, we fixed the database error, but we still have this other issue with the Waypoint API being missing. Okay, so the other way that I want to show how we can do this, as I talked about earlier, the very native integration with Waypoint and Vault. And what we're going to do here is we're going to actually inject some information into the environment variables for Waypoint. This will be made available through entry point, which isn't accessible from the pod itself. And we'll log in after and I'll show you kind of what I'm talking about there. Okay, so for the dynamic values, it's going to pull out of Vault. So I have this prepared here. So it kind of looks like this. So take a look. So it's going to create an environment variable called maps API key. It's a dynamic config variable that I can get from Vault. The path is kv hello creds, and the key it's looking for is map API key. Okay, so let's just go ahead and destroy that again. Service deleted, destroy, delete, successful. Great, great. And then let's just do a new deploy. Waiting for the service to come available. Again, we can show you this is dead. Got two dead ones now. So we can see version 10, version 11, they're dead. Just about there. Here it comes. All right, so this time around, what I want to show you. So we had it released with a load balancer. We're going to go ahead and grab this IP address. You can see that's available. Ooh, but something didn't work. Isn't that interesting? Again, fun with demos. Let's just check. To make sure that it was actually not working. Did I put it? Maybe it's not there. What are we looking for? It's there. Well, isn't that curious? So what was supposed to happen here, this application should have read this in. It does work. You can go check it out. I did it at HashiConf a couple months back, but I'm not sure what's going on here. Failed to read vault path. I know it's wrong. I know it's wrong. Okay, we'll fix this. We'll fix this. So I just know because of this error right here. Let me explain what I did here. Hold on. So Waypoint can get logs. It gets logs from that entry point layer I was talking about. When I check this log, I know that this is not looking in the right vault spot. So what I suspect has happened is that we haven't actually configured the Vault plugin. Let's fix that. All right. So in my README, I've got an example of how to fix up those credentials. So this right here. So Waypoint has a plugin for Vault. This is how it works. So we have it set to use the Kubernetes auth method. We tell it where what the path for that auth method is. We're going to define what the address is. We're going to tell it what role to be looking for. And because this is a demo environment, we're skipping the SSL. So let's go ahead and just copy this. Okay. And then I just can't recall if that's going to synchronize that. Yeah, it did. Okay, perfect. Renewed auth token. Let's take a review of this. Cool. So that was the issue. I just didn't have the plugin defined. Let's just recap real quick. So when I first showed it to you, it was still broken because I didn't configure the Vault plugin. Configured the Vault plugin using this stuff right here, and it was able to go and get the, can't see it here. We can see that it did grab it. And then if we do our Vault F0, let's just see if we can see it here. Let's just try this. Right. Yep, there. Okay, cool. So we can see that it's coming from here. We can see that it grabbed the Maps API key using that token. Okay, clear. So that's that. What I want to do really quickly, the last thing I'll show you before we get out of here and stop talking. And so I want to just get into this pod and show you okay, so I've exec into the pod. What I want to show you is, does this have bash? It does. Great. Sorry, I just forget where I got the so if I look, I just want to check. I think we're done with that other window for now. Okay, here. So what I just did here is I just printed out, you can see that it's mounting the DB creds. So remember the DB creds credentials are being populated by the Vault agent sidecar through the annotations. The other thing I talked about was the fact that with the API key, what we were doing is we were setting an environment variable. But what I want to show you is, if I look at the environment variable, on the pod, if I log into the pod, remember, I do not see that map API key. Okay? Not there. If I get out of here and I look at the Waypoint environment, okay, it's there. So remember, I keep talking about entry point. Entry point is part of the image that gets built into your pod, but it's not accessible from the pod. Waypoint is doing that communication to Vault through entry point. Makes it even more secure. So if someone gets a hold of your pod, they get into your pod, they can't just go and print out these things that it's got a hold of. For example, this API key, the way that it's being injected. So let's just recap what we've shown you, because I know we've kind of talked around in circles. We showed a very simple Go application. We showed it in a broken state. We did a deployment by updating the annotations. We showed it going and grabbing a dynamic database credentials that were rotated every 30 seconds. We showed you adding the environment variables. Let's just bring this down and show you again. We set up the environment variables here so that it would go and grab the some information from a key value path. Did that deployment, got a bonus, showed you how to configure the Waypoint Vault plugin. That's really all I wanted to show you. Let's just get rid of some stuff here. Bring me back up. Find where my demo is. So that was the demo. That's why I think looking at how we can get ephemeral credentials at deployment time, it's going to help with that security discussion. It's helping push that security discussion left further down the chain. It's letting people that are aware of how to handle things like security and bake it right into the platform. It's easier for a developer to move quickly, push my application out, and I know that's taken care of at the platform layer. The other nice thing with that is we can build some constraints around it so that even if they didn't think about that people can't get in just by other things that are natively available. Finally, last thing that's really cool is if someone did get in, there's a cool audit trail that we can find out what they did, how they did it, and just identify that blast radius. Hope you enjoyed the talk. This is my info over here. That's me on Twitter, and that's me on GitHub. Give me a follow if you want to have a chat. Love to hear from you. Thanks so much.
Fantastic. Thank you so much for that talk. I feel like it's always magical to watch Vault in action, to see people's credentials get rotated like that and just generated on the fly. Really, really fantastic to see.
You know, the other thing that's really fantastic to see is when people actually point to the right side of their screen in a mirrored situation, ad hoc. I always find this fascinating. I know you can train this. I know we can launch, multi-cloud, multi-cluster without any problems, but this is a really hard stuff. Also, still a very amazing demo. I love it. This today is going very well. I'm enjoying everything that's happening so far. We have next. I'm excited about this one.
I agree. Geo targeting easy, stage left, not a number. Next up, we have deploy federated multi-cloud Kubernetes clusters by 2, who's actually number 1 in my heart. So very excited to see this one get kicked off. I know that federation of Kubernetes clusters is that's also a hard thing to do. So very excited to see what 2 has to show us on that front. Let's get him all queued up here, and we will get that kicked off faster than you can say cluster. Well, maybe not.
Cluster.
Awesome. It's like, here we go.
My name is Tu, and I'm an education engineer at HashiCorp. Welcome to this talk where I'm going to go through how to deploy a federated multi-cloud Kubernetes cluster using Consul. This talk is heavily inspired by a tutorial written by Rita, a fellow teammate. I'm going to be referencing this tutorial throughout this talk, so just so you're aware, to get to this tutorial, first go to our Learn page, and then type multi-cloud. From there, it should be the first search result. With that said, let's get started. So let's assume that we're Megacorp and we have a Kubernetes cluster running on AWS. We're doing so well that we acquire a startup that also has a Kubernetes cluster, but it's running in Azure. Now we're tasked to configure the Kubernetes clusters in a way that services in one cluster can talk to and interact with services in another. One way to do this is to spin up console data centers in each cloud provider and then federate them. Console provides a secure service mesh that facilitates encrypted communications between your services, ensuring multi-cloud infrastructure. Because of Terraform's large collection of providers, we can use this to spin up everything from the console data centers in each cloud providers to federating them to spinning up services in each Kubernetes clusters after we federate them, just to confirm that they can indeed talk to each other. So with that said, let's get started. So this is the actual configuration, and in this repository, HashiTalks deploy multi-cloud Kubernetes, we have the AKS directory, the console directory, and the EKS and HashiCups directory. First, I'm going to open up the EKS directory, so cd EKS, and in main.tf, you'll see this is a pretty generic configuration to spin up a VPC and an EKS. And then in outputs.tf, you'll see that it should return the cluster ID, region, and cluster name. Because I already spun this up right before this talk, if I run a Terraform output, it returns the cluster ID, name, and region. Same thing for the AKS directory. This spins up a resource group and a AKS cluster, and then the outputs returns a resource group name and a cluster name. So if I run Terraform output, it should return those two items, and it does. So now what I want to do is configure config to access and interact with these clusters using kubectl. If you go to the tutorial and go to configure kubectl, there's this nifty command where if you click on it and then paste over in the EKS directory, this command will automatically update your kubeconfig with the EKS information and store it in the EKS context. You can do this with the AKS directory too. So first navigate to AKS and then paste this command. And it saves all the information you need to access the AKS directory in the AKS context. I'm going to overwrite my existing one and we're good. So now I can run kubectl get pods context and EKS, and there's currently no pods running, so that's right. And then I can do the same thing for AKS, and that's also right. So moving over to the console directory, this is where the interesting stuff happens. I'm going to run a Terraform apply and auto approve because this takes a while to spin up. But the console directory is where all the interesting stuff happens. This is where we define the Terraform configuration to spin up the primary data center in the EKS directory. This is also where we add the Kubernetes Secret into the secondary data center and spin up that console data center in the AKS cluster. And last but not least, this is where we also create the proxy defaults. I'm going to cover what that does as soon as we get to it. But as you can see here, it will add 3 new resources. So first, in the EKS file, at the top, you will find a remote state. And what this does is it pulls the state from the EKS workspace that we provisioned our EKS cluster from. And with that, it configures the AWS provider. And that allows us to pull the cluster information from that EKS cluster that we provisioned, and we use that information to configure both our Kubernetes and our Helm providers. Notice that both these providers have an alias to the EKS. That's because we also have another set of providers for Kubernetes and Helm in the AKS file, but instead of EKS, they're for the AKS cluster. Next up, we have the Helm release, and what this does is it spins up a console data center in the EKS cluster, and the console data center configuration is pulled from this DC1 YAML file. I'm going to open up this DC YAML file so we can go through it. So the first thing you see here is this data center name is DC1. It has TLS enabled because TLS is required for mesh gateways, which is required for console data center federation. Next up, this federation field is enabled, and the create federation secret is set to true. So if you want to federate multiple console data centers, you must designate one of the data centers as the primary, and the primary one is the one that creates the federation secret. Within the console federation secret, it has information for the certificate authority, which signs the certificate that console uses for the inter-data center traffic. So that's what we have here. Since this is the primary data center, this is why we have this set to true. Next up, you'll see that ACLs are set to false, which is completely fine for this demo and this talk, but please, if you run this in production, set this to true. Next up is the connect inject field, which is set to true, and it's enabled by default. Connect inject tells console tells the Kubernetes clusters to automatically add sidecar proxies to each pod. Give me a second. So this configures your cluster to automatically add sidecar proxies to the pod. Since this feature is enabled by default, all pods will have sidecar proxies unless specified otherwise. And I'm going to show you what this looks like when we spin up the actual microservices after we're done with federation. The sidecars route traffic to upstream services located in other data centers using the mesh gateways. Speaking about mesh gateways, last but not least, we have the mesh gateway field, which is enabled. So now that we're done reviewing DC1, the next data source in our EKS file is this EKS secret. Like I mentioned earlier up here, since create federation secret is true because this is the primary data center, the console Helm chart will create this console federation secret that we need to import into any secondary data centers. So in this case, it's the AKS cluster. Also notice that this data source has an explicit depends on. What this does is it tells Terraform to wait for this Helm release to completely finish before pulling this value, because this Helm chart creates that secret. So you can't pull the secret if it doesn't exist. All right, since now we're done reviewing the EKS file, I'm going to jump over to the AKS one. So the AKS at the top, it's very similar to EKS, but instead it pulls the information from the AKS workspace. Down here, this data source pulls that information from the resource group name and the Kubernetes cluster to authenticate both the Kubernetes and the Helm provider. Notice here that the alias is for AKS and not EKS. And then down here, this is the Kubernetes secret resource that imports that console federation secret that we created in the primary data center. The data here points to this data source. And since it points to that data source, there's an implicit dependency. So Terraform knows, hey, we should wait for this resource to finish creating, then propagate this data source. And then once this data source is propagated, we can begin to create the Kubernetes secret in the AKS region. Next up, after this Kubernetes secret is created, Terraform will spin up the Helm release for the second data center in the AKS cluster. This Helm release will wait for this Kubernetes secret to finish creating in the AKS cluster before creating, because the second data center requires the Kubernetes secret. So the DC2 YAML file contains all the configuration for this secondary console data center. So DC2 is very, very similar to DC1, but there's a couple key differences. Notice that data center up here is now DC2 instead of DC1. If you plan on federating multiple console data centers together, the data center name must be unique. Under TLS, this is also enabled, but unlike DC1, it's using the CA key inserts from that console federation Kubernetes secret that we imported from the primary data center. Down here, federation is enabled, and because this is the secondary console data center, it doesn't have that create federation secret attribute. And then everything else is pretty much the same as DC1. Connect inject is enabled and true by default, and mesh gateway is also true. So now that the console data centers are created and federated through AKS, through the AKS and EKS files, I'm going to go into the default proxies and uncomment out these two resources. So what proxy defaults do is it tells console to, or it tells and configures the sidecar proxies where to route their traffic. As you can see here, under spec in mesh gateway, the mode is set to local. So what this means is that the pod or the sidecar proxies will send traffic from the pod to the local mesh gateway before sending it to the remote, so the secondary data center's mesh gateway to its final destination. The other mode is remote. So what remote would do is traffic will start from the pod, but instead of going to the local mesh gateway first, it will go directly to the remote mesh gateway before going to its final destination. It skips that remote mesh gateway hop. So I'm going to run Terraform apply and auto approve. And the reason why we have to apply this after the EKS and the AKS ones are spun up is because these two resources use the CRDs, which get created during the initial console Helm chart spin up. So whenever you apply that Helm chart, it will create the Kubernetes proxy default CRDs. And if you don't run this the second time, it will error out because those CRDs don't exist. So Terraform doesn't know what to do. So now this is complete. Everything should be set up. So just to confirm, back in the tutorial itself, let's go to this section and then scroll down to verify cluster federation. So first thing that we want to do is list the pods in the default namespace in the EKS cluster to confirm that the console pods are running. So I'm going to copy this command and paste it in. And I should see the console pods in the EKS cluster, and I do. I'm going to do the same thing for AKS. And I see the console pods are running, and that looks good. So I'm going to go down and run this command. So this gets the proxy defaults from the AKS cluster. And since this is true, I verified that Terraform did apply the proxy defaults and everything is working as expected. Last but not least, I'm going to run this command. What this does is it verifies that the clusters are federated by listing all the servers in the console's wide area network. So I'm going to copy this command and then paste it over. Awesome. It looks like everything is working. So I'm going to move on. So in this step, I've spun up the console data centers in both EKS and the AKS region and federated them. The EKS region is the primary console data center, while the AKS cluster is where the secondary data center DC2 lives. Now that we've done that, I'm going to go open up HashiCups, and this is our demo app, and I'm going to spin HashiCups up in both the EKS and the AKS region and see if they interact with each other. So like before, I'm going to run a Terraform apply auto approved. And while this runs, I'm going to explain what this configuration does. So in HashiCups, I'm going to open up the backend file first. So HashiCups-be. So in here, like before, I'm pulling all the remote state from the AKS directory because I want to deploy the HashiCups backend to the AKS cluster. I'm retrieving more information about the cluster here, and I'm using that to authenticate to the Helm provider. And notice here, it's using an alias for AKS because in the front end, we're deploying to the EKS cluster. So the first Helm release that we have here is the product API DB. We also have the product API, the payments, and last but not least, the public API. So I'm going to go through the spec for each one of these Helm release because it shows you how the dependencies work with console. So first up is the product API DB. So I'm going to go into templates and then the product DB. Here it defines a service and a deployment. It spins up a deployment named Postgres, and then down here under annotations, you see an annotation called console hashicups.com/connect inject, and that's set to true. I didn't need to include this in this configuration because if you remember in both DC1 and DC2, we have connect inject enabled and set to true by default. But then for some reason, if you want this pod to not have a sidecar proxy associated with it, this is where you would flip this from true to false. But we don't want that, so I'm going to keep it as true. Next up, we have the product API, and the product API uses the product API DB. So I'm going to do the same and open up this YAML file, and it defines a service account, a config map, and a deployment. The deployment is named products API. In annotations, you'll see the connect inject set to true. But here you also see something new, the connect services upstreams. And this is pointing to Postgres and the port for the Postgres service. This is what the product API DB service is named. So that's why we have Postgres here. Next up, we have the payments microservice. The payments one is very similar to the DB one because the payments one doesn't have any dependents. So here it defines service account, and deployment. And as you can see under annotations, it's only the connect inject is equal to true. Last but not least, you have the public API. So I'm going to open that up, and as you can see here, there's a service. It's running on port 8080, and you have the deployments, and the deployment name is public API. Down here, connect inject is true, and then since the public API sends requests to both the product API and the payments one, under connect service upstreams, it has the product's API service running on port 9090, and then payments running on port 8080. So this is how console knows where to connect these services. Now I'm going to review the front end. So at the top, remote state is very, very similar to the backend, but it's pulling from EKS, and then it uses it to authenticate to the Helm provider. Notice that the alias here is EKS. And then it only has one Helm release, and that's for the front end. And then it uses this values file just to configure it. So I'm going to pull up the front end YAML file so we can review it. It defines a service, a config map, and a deployment. The deployment is named front end. Like the others, connect inject is set to true. But unlike the others, the front end interfaces directly with the public API. So connect service upstreams is set to public API, which is running on port 8080. And then I specify the second data center, so DC2, because that's where the public API and the rest of the backend services are. They're in the AKS cluster, which corresponds to DC2, where our secondary console data center is set up. So now, since everything is up and running, I'm going to run kubectl get pods or get deployments for the EKS cluster, and I see the front end service running. I can do the same thing for AKS, and I see all the services for the backend running on the AKS cluster. So what I'm going to do now is I'm going to do kubectl port forward service front end, and I want it to run on port 8080 on my local machine, and it's running on port 80 and context EKS. So now if I go to localhost 8080, I should see the HashiTalks app, and everything is running as expected. If I refresh this, it takes a second, but if you look down here, you will see, give it a second. You'll see that it connected to the API, and then the API is returning a value. So everything is working. The services are interacting with each other, both within the AKS directory. All the backends microservices are talking to each other because the public API is talking to the product API, and then that in turn is talking to the front end service, which is how we're seeing this. because everything is spun up in console itself, what I can do now is run a kubectl port forward. And then give me a second. And then I can also run console server -0. It's running in port 8501 and 8501, and then context EKS. Oh, I should spell that correctly. Oh. So I'm going to close this real quick. So what this allows me to do is connect to the console dashboard. So now if we go to localhost 8501, advanced and proceed, let's go to the main dashboard. And since we're in DC1, there's only one front-end service that we should be seeing, and that's what we have here. Within this, I can also select DC2. And then in DC2, we have the payments, Postgres, products API, and publics API as we expect. So the neat thing about this is, since we have console running on both data centers and we're using it as a service mesh, we can define things like intentions. So for this, if I tell console I want a new intention that blocks traffic from the front end to the public API. So front end and then public API, and then I deny it and then click save. What this tells console is, please block all traffic from front end to the public API. So if I go back here and run this command to connect to the two HashiCups, and then refresh this, give it a second. This takes just a quick second. And as you can see down here, API is not responding. And that's because under intentions, we've blocked it. So if I now go back in and connect to the console dashboard and click on this and set that to allow and click save and rerun the front end. Let's reload this. Now, since console is allowing traffic to flow from the front end to the public API, HashiCups is working as expected.
Awesome. Thank you so much, too. That was really, it was great to see that you had good intentions at heart and in your demo. So thank you very much on that front.
These are definitely good intentions. The thing I really regret is not having access to an API that can get me caffeinated drinks at any time of the day.
It's the APIs might be open 24/7, but you're right. The stores might not be, and that's a very sad thing.
Yeah. So with this, we're nearly at the end. We've got one more talk left. This one is a little bit different. This one is more on culture, and I'm excited about this. But before we kick that off, I have a question for you, Taylor.
Of course.
For $100, which set of principles and practices hit 18 years of age earlier this year?
Interesting. Well, I know it can't be DevOps or Kubernetes or Nomad.
Most recruiters won't know this.
Is it SRE?
It might just be. I think, you know what we're going to do is we're going to switch over to Martin and let him talk about reliability as a product feature.
I mean, that sounds like a pretty reliable thing to do, but okay, cool. With that, we'll kick off, Martin. Thank you.
Yeah, so I'm Martin Smith. I'm a site reliability engineer at HashiCorp, and I have this idea that I'd love to talk to you about called thinking about reliability as a product feature. And it's really not a new idea. It's something that uh, goes kind of back to the beginning of what SRE was supposed to be, but maybe something that we haven't thought about as much lately, and I'd love to bring it back to that. So again, that's me. My pronouns are he, him. You can find me on Twitter at MartinB3. Um, and I've had lots of roles as a DevOps engineer and a site reliability engineer in the past. I've been a tech lead for an SRE team. I have had many opportunities to define the role of SRE, what activities they do, and more importantly, like try to figure out what the impact of an SRE team should be. So I've worked on that a bunch, and hopefully some of these ideas will give you some ideas about how to do that on your own team. So first, kind of just wanted to talk about what SRE is. So SRE at its basic is treating operations as a software problem and use software engineering techniques. I'd say this isn't surprising given the timeline. You sort of had Agile in the 80s and 90s being applied to software development, and it was basically time for people to start thinking about software engineering for other parts of the tech world aside from software development. So here's sort of this timeline of 2003 when Google started doing SRE as the first place that did that. Usenix in 2014 started doing an SRE con. Google published this SRE book, which a lot of folks follow pretty closely. I put a note there because even Google says not to follow it exactly, adapt it for your organization. And by 2021, a lot of data shows that like a fifth of organizations doing some kind of technical role have an SRE role in it. And SRE is as much a philosophy as a set of skills. We'll talk about that some too. So thinking about what SRE does, there is one like a downside to SRE that a lot of folks talk about, including the gentleman that originally founded the SRE team at Google, which is if you let SRE constantly sort of improve, continuously improve, they're slowing down the firefighting that used to happen before SRE was a thing. So it sort of can be a discouraging thing, is that SRE is just kind of like slowing things down, or SRE wants to write code instead of fixing the outage, or things like that. So a lot of folks would say you can't really succeed with SRE without thinking about DevOps. It's totally cultural, and also you can't really succeed with SRE without thinking about things like cloud native architectures, right? They go hand in hand. If you can't go back to some software that was deployed in Windows in 2003 and just put SREs on it, if they don't own the source code, that's not going to work, for example. So SRE has a lot that it has to do, right? It's not just a philosophy, but it is a philosophy and a skill set, and there's a lot of skills in there. So I kind of wrote some of these down. I looked up some definitions of SRE. It's really an overwhelming set of things. If you look at just the list of what SRE is responsible for some organizations, that's practically all they do. Everything from emergency response monitoring, efficiency, performance, latency, so much. Even just picking one item like observability, look how many tools, just Googling, that I was able to find that are on observability. So holy moly, an SRE is not going to know all of those things, right? But I think we also know that SREs do a lot of things. And in our industry, those things, are this long recitation of things like incident management, retrospectives, what else? All of these observability tools, all of these like chaos engineering, all of these, just this whole set of practices that SRE does, that if you look it up, I feel like we might have lost the forest for the trees, or the trees for the forest, so to speak. Reliability at the end of it and at the beginning of SRE was about a product feature and making a product reliable. I've also found that when I'm trying to explain what SRE is to business leaders, often I go back to this definition too, right? Which is if I can't explain how what SREs do affect customers directly and the reliability that they're thinking about, it's usually a sign that I'm not working on the right things as an SRE. So one caveat to that is sometimes an SRE is about making that role is about making people more efficient internally because we know that that makes our customers have a better experience. But ultimately, you should ask yourself, like, can I tie this back to why the customers are having this good experience, right? Am I doing something that helps there? So shifting that focus back to thinking about reliability as a product feature. So one thing that this does, if we just keep thinking about it as a product feature, is it helps organizations really even just think about what reliability is for their product, right? That could be like resiliencies, that could be like fault tolerance, that could be something like scalability. Can I throw a bunch of work on it as a customer and expect that it'll actually give me results? Scalability, observability, rather. I think understanding the internal state of a system from its outputs. Security, do the customers trust that the thing is doing what it wants? These are all product capabilities that aren't often well understood. I put a quote at the bottom of this slide because a friend of mine likes to say that reliability is a product feature whether you devote engineering time to it or not, right? So your customers know how reliable your product is, whether or not you've actually developed any kind of actual functionality to make it reliable. I'd also say, like, it's really important to argue that reliability benefits from product management support. So product managers, we love them. I wish I had more of them in every role I've been in, but they do things like they help communicate with stakeholders, they build roadmaps, they help with prioritization. Like, for example, thinking about reliability as a product feature, what do you know who your internal stakeholders are for the scalability of your product? Like, do you know the development teams that are throwing work at your product or adding features and then expecting it to actually be able to run those for customers? What's on the roadmap for the observability of your product, right? I think that's a real popular discussion these days is like, what are we doing with logging? What are we doing next with logging? What does 6 months of that improvement look like? What does 2 years of that improvement look like? And most importantly, like, what metrics are you collecting to be sure you're actually delivering on that roadmap, right? So that's like classic product management. And we often don't get it in SRE as product management. Sometimes technical folks end up wearing the product management hat. It's also important to think about how it aligns with other features and roadmaps, right? If you're planning to release some feature for your product that doubles the amount of work it does, well, guess what? Observability matters. The performance and scalability matters, right? Even if you're developing a feature that's going to bring in 10x the number of customers, like that's a huge thing. And I hope you're thinking about reliability when you're going to 10x your audience. So yeah, again, if you don't plan for reliability specifically, your customers are going to get what they get and make their own assumptions about your reliability. This happens all the time if you see out in the industry sites or products where people know that they're unreliable and the customers get frustrated because customers know about the reliability of your product, whether you do or not. So it starts to sound like any other product feature, right? I've argued for product manager, internal, external stakeholders. That's all by design, like making it explicit as part of your organization's planning. Organization's planning has many benefits, I think. I put this quote, there's this ThoughtWorks technology radar, and the most recent one came out in October. And they actually talk about the trend of thinking about internal teams having products and thinking about themselves as product teams, just like external teams. They actually cite the team topologies book, which you could check out for how to organize your teams. But when I've looked up what teams are doing around team topologies, I also find this framework from Simon Wardley called Pioneer Settler Town Planner, or I'll call it the PST framework. So I want to kind of tell you about that framework, and actually think it's really helpful to organize ourselves as SREs and think about what we do as SREs. So again, I think this is worth reiterating. There's no one-size-fits-all approach to reliability. As I've seen, just showing you all the things that SREs do for reliability, you should know there's not, depends on the stage of the project, it depends on the team, it depends on the organization, all of these things. But what I'm going to do today is break this down into beginning projects, growing projects, and established projects. And then I'm going to show you the PST framework and how that ties together. So here's the PST framework. And basically this is saying at different maturity levels, you need different kinds of behaviors for a project, right? So pioneers are doing things that are inherently uncertain, lots of experimentation, sometimes poorly defined things. Maybe we're not sure how the product is going to fit into the rest of the work. It's okay to fail at that stage. There's lots of experimentation. There's lots of like delay of things to do and accomplish later that you might not accomplish right now. And they have to typically be pretty agile. And, you know, this is graph here kind of, or this diagram here shows kind of what that looks like and what even the life cycle from pioneer to settler to town planner, what the relationship looks like. So settlers, same thing, sort of like growing differentiation, like starting to constantly improve from just experimentation, start listening to how people use a product or a feature. And then town planners are kind of like probably the least popular type, if we apply this to SRE type of work, which is defining process, doing operational efficiency stuff, doing modeling. This is where chaos engineering probably falls. So this is this framework of pioneer, settler, and town planner. I encourage you to kind of read through it, look at the graph or the line at the bottom about how something becomes like an idea to a product, to a commodity over time, and how they relate to each other. So now what I'd like to do is kind of talk about some engagement models that SRE can do. So one example of this would be consulting. So you might have SRE office hours, or you might be available for questions, or you might do something where there's sort of a short engagement. It's quick, it's defined, it's in an hour. A lot of SRE teams actually kind of funnel work into this model because otherwise they're overwhelmed by it. So, you say, gosh, this other team is asking for help constantly. Let's pick an hour every week and we're going to get together, and that's consultation. And that works really well for some levels of the PST model there. So also process improvement is another way that SRE can really impact the organization. So that's like looking for reliability or scalability patterns that show up and then trying to implement processes to improve them. So this might be an incident management process or an incident action item follow-up process. It might be production readiness. You might be building a process and framework for releasing new features. It could even be something like SLO and SLA programs and what a process and like a repeatable program for that looks like. There's also project collaboration is another one. This is usually really well scoped, like we're going to deliver this product and we need an SRE to help us. So this is like maybe you might take a project to implement rate limiting, and like SREs and other software developers might pair together to propose how to do it and then implement that functionality. There's lots of other ones here. Basically anything where you're sort of pairing together, I would call project collaboration. And then there's two others. One is embedding, which is sort of being a member of the team that the SRE is joining to embed onto. You see this mentioned in the SRE book a lot. I'll just call out, I put a star there because I want to call out that the SRE book makes it really clear that when you embed, you're a member of that team. Embedding is not dropping in for a sprint. Embedding is spending time to onboard and you might not be the most senior developer on that team, but you're definitely a contributing member. You've lived what that team has lived. You've walked in their shoes. And then for an SRE doing an embedding relationship, you're sort of leveling up the team, being a multiplier on the team. So once you're a member, you sort of have some free time compared to the team's roadmap, but you know what the team is going through, and then you can actually say, all right, I'm going to teach the team things that they need to know or help the team accomplish things they couldn't do by themselves. But you want to be a multiplier. You're not just another warm body to throw roadmap items at. And the last one that I want to mention is ownership. So SRE could introduce components that improve the reliability of a system. This could be a Kubernetes operator to improve fault tolerance, or it could be like that rate limiting project we talked about before. And at some places, SRE might even own rate limiting. But these are the kinds of things that when there's ownership, SRE and the teams that are affected should be like regularly reviewing them to be sure that it makes sense for SRE to own them long term. Because if SRE continues to just take on ownership of things, that eventually becomes unsustainable because they either end up with a lot of toil or they can't like do some of these other engagement models because they're too busy owning stuff. So we've talked about some engagement models. We've talked about this PST framework. So I want to say, what would a Pioneer SRE do and what engagement models might they use? So if you think about Pioneer, that's like new projects, right? That's a small change could have a large benefit on a project early on. Experimental work early on might be completely discarded, like a prototype that's discarded. It's really important to have SREs in these early stage projects because they ask questions about reliability early and they can help teams make decisions about reliability early, right? This could be as simple as making a product vendor choice that if the team didn't have SREs involved, they might not actually pick the most reliable vendor. But also SREs can help with that experimentation, agile decisions, failing faster, but always thinking about reliability. You always want somebody at the beginning of a project involved that is thinking about reliability. So that can be SRE. So have you ever seen a project get close to being released without thinking about reliability or even just operational concerns like work you have to do every week to maintain a product? Pioneer SREs are really a great opportunity here. So they should be part of a team. They should help do the delivery. They should help evaluate vendors. They should build out proof of concepts with your other development teams. And they should be also talking about the architecture and what it means to make the changes for the project and how it affects your larger architecture. At this stage, like any work to sort of cover reliability gaps could be identified by SREs, or again, you could make a totally different decision or direction based on concerns raised by the team. Embedding, talking about those models, embedding is a great opportunity for here. Brief consultation for reliability doesn't always work because often the final output doesn't actually reflect those concerns about reliability or operability. So embedding is really a really great opportunity for an early project with some Pioneer SREs. Their success, how do you know whether it's working well for pioneers that are embedding, is how quickly new products and features get launched, how quickly vendors implementations happen, how quickly something moves from exploration to concrete proposal. That's another way to measure how successful SREs in this model are doing. Probably the largest risk in this phase is having SREs end up being owners. So this is that we talked about back in a few slides ago, ownership being something SRE can do. If SREs end up owners of a whole project or product, they'll end up getting treated like sort of the ops team for a product. And that's all the toil that SREs don't want. That's the ownership that's unsustainable long-term. I'd say if you can help it, do really well-scoped embedding engagements with SREs and products, and emphasize that they're sort of a multiplier resource or a training resource. They're not coverage for the team once this product goes into production. That's probably the biggest risk I've seen with embedding. Now you think about a product that's sort of gotten off the ground that you're building, there's customers starting to use it, it could be in beta or alpha or something like that. It's great to have think about SREs as sort of settlers in the PST framework for a project that's in the sort of middle phase here. So what could SREs do in a project like that? I think that they could help build and mature things, right? They can look for new operational burdens. They can find toil and help automate it away. You can continue to embed at this stage too, if you think about what sorts of engagement models SREs do for this stage. It's actually great to have SREs like involved in the launch of some product or feature. Consulting for SREs also works here, especially if it's a brand new team or a brand new service that's launching. SREs can really help ensure everything is production ready and it meets the requirements for reliability, as well as like operational best practices like, for example, SREs in this phase might encourage a team to do automated database migrations instead of manual ones on the command line. I think at this phase, having an idea of production readiness is super important. This sort of drifts a little into the process type engagement, but SREs that are thinking about like operational readiness can create sort of a minimum bar for a team to say like, you have to at least be able to be on call or be able to respond to something. SREs at this stage may even help build some of the automation or on-call things, or even like auto-scaling, that kinds of things when you're sort of productionizing something. The success of these SREs in this phase could be measured at like how many new services are going GA or taking customers. What does observability look like? Is there effective logging and metrics and monitoring? Success in this phase is also about establishing patterns that make projects successful, right? Like, so SRE might say, we've seen 10 other teams we've helped in this phase do X and therefore be Y successful on some particular dimension. So SREs in this phase quickly become the town planner phase, in my opinion, just because they're constantly looking for the processes and the patterns to improve a project. Again, there are risks at this phase too, which is that sometimes at this phase, things show up at the very last minute as far as need. That could be unfortunate. Coordination can be a little harder in this phase, especially if a team is racing to get something to production, but a SRE team might not be really, the timing might not be right there. So thinking about town planner SREs, so this is sort of like probably the black sheep of SRE activities. A lot of SREs don't love this type of activity because it's really hard to see the impact you're having, because it's process is such a hard thing to see the impact of. In this most mature phase, products and services are already GA. There's already customers. And SREs are starting to look at, town planner SREs are starting to look at some systemic issues. So overall architecture problems or developer tooling that impacts reliability. I think SREs can influence here, like what kinds of things can they do? They can influence continuous improvement overall. They can identify systemic issues like repeated incidents or poor SLO choices, or maybe lack of an on-call process. Driving continuous improvement, again, is like one of the best ways SREs in the town planner role are effective. In addition, they can often find ways to eliminate operational pain or toil, especially large-scale toil, whether that's through like implementing automation, right, which is the biggest tool in an SRE's tool belt, automation, or even things like architectural changes, or this is the part that's less exciting for a lot of engineers, is by developing process or knowledge or skills or training, tooling, helping people learn, which can be applied, like this kinds of learnings or tooling or process or whatever can be applied large scale repeatedly to projects to make them successful. There can even be, as I said, this stigma attached to it, but the impact of it I can't overstate. SREs really act as a true multiplier in this phase, just like a town planner would for the impact on every neighborhood in a town, right? Some ways to sort of ameliorate or address this concern about SREs not doing as much technical work is to pair them with like technical program managers or product managers. Again, thinking about this like any other product. Pairing them with people who can help drive process and strategy is really helpful, because then SREs can focus most on the technical aspects of what they're improving, while these other roles like a technical program manager can help with the organizational changes that are needed to improve something or implement a process or execute on something. Measuring the success of these, let's see, it's especially tricky for town planners, I would say, because simple metric improvements are often misleading, right? Like fewer incidents, reduced incident impact, or the reduced pages that you might see, or improved SLOs. SRE impact is more than that, I think, in this stage. Qualitative impact is really important to figure out here. Talk to the SRE team's internal customers, the teams they're collaborating with, and understand qualitatively if it's SREs at this stage cause paradigm shifts, right? They help people think about on-call totally differently, or they help people think about some incident process totally differently, or they help with things that are really big, like, mind-blown kind of changes for the organization here. And often that's not even true of the other SREs, right? An SRE might help a team do incident management differently, and the other SREs on the SRE's team might not even know. So town planner is tricky, but all engagement models do work here, I would say. Just kind of like taking a step back from that sort of like pioneers, settlers, town planners model, and then some of the engagement models. I hope this is useful so that you can kind of pick what project is at what phase, and then pick SRE activities that really work at that phase. I will say that like sort of taking that step back and looking at reliability as a product feature, it's not a magic bullet, right? Like it doesn't help an organization that doesn't understand where its product fits in the market, or like what kind of value the product delivers, or like if product management isn't available or is not helpful or has a bad relationship with the development teams. Throwing SRE in the middle and treating it like a product is not going to help. It could also be that if a team really can't like design and deliver their features, adding SRE to the mix is not going to help there either, right? So this ties back to sort of what I said at the beginning, which is there is no one-size-fits-all approach to SRE. So you kind of got to pick for each project, like what does it need, and use these tools. It might even be as simple as using some rules of thumb in addition to these. This is really popular with SREs, right? So a lot of SRE teams do things like they say, no more than 50% of our time will be spent on toil, or maybe every product feature that goes live must have some sort of like reliability metric or something like that. But combine those rules of thumb with some of these strategies for engagement and then at particular project stages. And I think that should help focus a team to make the biggest improvements they can to reliability. I did put some other things on this slide here because I've done some research on like how different teams are doing SRE and how organizations are doing SRE. Continuous improvement is a huge theme on all of them. SRE collaboration with other teams is a huge theme. That collaboration can make it or break it for the effectiveness of an SRE team. It can jeopardize a whole product launch. And I put some other things that embedding is very popular. Having some of those best practices is very popular. Check out this How They SRE repo too. And actually, if you're doing SRE, do a pull request there and submit how you're doing SRE. I'd love to hear about how other teams are doing it and what works for their organization. Again, no one size fits all. But I do like this quote, which is from Simon Wardley that developed that framework, the PST framework, that says like, take a highly effective company and the PST framework will push it towards being more continuously adaptive, right? So looking at where projects are in their life cycle and then doing the best things for those projects at that stage. That is the end of my presentation. I hope me sort of combining these two themes about pioneers, settlers, and town planners, and then engagement models, gave you some ideas about how to do your own SRE team, or things that you may not be doing today, or things like embedding, which maybe you're not doing as well as you'd hoped, and maybe it's time to start doing a regular retro on it or something to kind of figure out how to do better. In addition to giving this talk, I've started a Gainesville, Florida HashiCorp users group. Check that out on Meetup. There's also some other resources here if you want to start your own HashiCorp users group, or the doc site, the learn site, or the discuss site if you want to post. Please post and talk about some of these cultural things on the discuss site. There's lots of folks there using HashiCorp products, but are also going through organizational or cultural change. Thank you. Thank you again very much. I, again, invite you to write about and share your own experiences, whether they're good or bad, about taking reliability and thinking about it as a first-class product feature at your organization, and thinking about it not just as all of these activities that SRE does, but like what is the actual impact and outcome of them? And that should be, I think, reliability as a product feature. So again, thank you so much. I'd love to hear more about what you're doing. Do a pull request to that How They SRE repo earlier. And thank you again.
All right. Wow. Well, 2 days just breezed right by. It felt like a lot of time planning, getting these speakers coordinated and reaching out to them and working with them to get all of these talks, but truly fascinating. Thank you so much, Martin, for kind of walking through all of the things that are worth considering when it comes to SRE. I know it's something very difficult to right? It's difficult to get correct. Just like we talked about earlier, with Cole, it helps to measure twice and only cut once. Especially when you only have the budget for once.
You can't redeploy everything. We deployed for 2 days, today and yesterday, and thanks to y'all, we had some really, really amazing sessions. All of this will be on YouTube. We'll have playlists for this event available. Follow the YouTube channel, click the like and subscribe button. If you haven't already, we gotta say this just to make sure you can find them later, because people do email us. Where can I find this? It's on YouTube. Follow us on Twitter. We'll talk about this there. If you would be interested in speaking at one of these, reach out to us as well. We've got new themes coming up next year, and we're bringing back old themes. I think the next ones are on connectivity in the widest sense of the word, security, strong focus there on everything IAM, Vault, Boundary, things like that. If that's of interest to you and you have a story to tell or learning to share, let us know.
Absolutely. And if you have any fun use cases or any things like that you can think of, again, please let us know. We're always happy to kind of talk with you and figure out the fun solutions that you've come up to interesting problems.
I think with that, we're at the end of today. So if you're still here, just close the browser tab. We're gone.
We're out of here. We really appreciate you coming by. We had a blast seeing and producing and working with you. Big shout out to all of the team for making this possible. And again, catch us on YouTube. We'll see you around the internet. Thanks, everybody.
Bye, everyone.